Go ahead, Sylvia. Someone pressed start by accident.
So shall we start or shall we wait a few more minutes?
Let's start.
Okay. Well, good morning, everyone. Now I can see you. Welcome to this Sustainable Places paper session on the last day of this conference. I'm glad you're all here. We have quite some time, but we also have quite some interesting presentations on the program. And I would like to show you how I envisage the program. I cannot see. Let me see. Yeah, can you see the program?
I did, but now it's a black screen.
What happened? Is it something I did or?
No, there it is. There it is. Now just put
Okay.
it in presenter mode, please.
Sure. So we have let me see, 1, 2, 3, 4, 5. Yeah, we have some 7 presentations, and we will try to make sure that we can all presenters can have like 20 minutes, so that the final presentation also will have sufficient time, and that afterwards we will have the remaining time for final Q&A. But since we have many presentations, I also propose that after each presentation, if the presentation is within 15 minutes, we have 5 minutes for Q&A before we continue to the next presentation. And when you present, when you have like 2 minutes left, I will briefly interrupt to remind you of that, so that we can make sure that we all stay within the 15 minutes as good as possible. That's from my side, the introduction. I think it's if there are no questions, that we should start. And our first presentation is by George Huitema from the Dutch Organization for Applied Scientific Research, or TNO. And his presentation is on demand response optimization in buildings and energy communities, a case in value stacking. That's the title. So George, Zia will give the floor to you.
Okay. Good morning, everybody. Try to find my screen. Can you see my screen?
Yes.
Yes.
Okay. So it's early in the morning. Okay. Thanks, Sylvia, and the organizers for this opportunity. Let me introduce myself further. Sylvia said I'm employed at TNO. I'm a senior scientist, work in many international and national research projects in the energy domain, and I'm also a member of the international group of the ETIPSnet. I also have a chair at the University of Groningen on ICT and business, and that's also this presentation perfectly falls in that affinity. This presentation is a result from the Horizon 2020 project Holiday. You can see also the logo here. Yesterday, the program coordinator of Technalia, Pablo, already presented it in the session on sustainable digital tools. And that presentation was mainly on the technical part. There is a poster available and of course a conference paper, but I will focus here more on the business innovation part. There's a work package dedicated to that, and I'm the work package leader. All the co-authors you see on the screen are also participating in that work package. And finally, and then we can start on the topic. Besides this project Holiday, I'm also TNO project leader of Making City, and I already saw some of my colleagues, Rosa and Beril, who will also present in this session on that project. So let's start. My title is Demand Response Optimization in Buildings and Energy Communities in Case of Value Stacking. And there are 3 keywords here, and I will go into that further. That's demand response, energy communities, and value stacking. So demand response. Demand response is an umbrella term. It's about programs that stimulate prosumers to make changes in their energy demand. And one of the main techniques, mechanisms there is flexibility. And flexibility is the ability that you can bend, that you can adjust as a prosumer, the power you take out of the grid or you feed into the grid. And that has value if you are able to deliver flexibility. It's the same. I travel by bike to this location day. About road pricing. If people are flexible, and of course the pandemic shows that we are all necessity, but that if you can change your demand, then you that has value and you can be compensated for that. It has value. There are very nice papers of the USEF Foundation explaining all these flexibility mechanisms. In particular, they talk about value chains, how it can be delivered, which actors are involved, and the new markets about flexibility. And the co-author Alina had worked at the USEF Foundation, and we heavily use these results. I can recommend. So yeah, let me introduce this presentation. What is the current situation about demand response? Well, the last few years we have seen a lot of pilots, and during this conference there were also many presentations on pilot sites and technical pilots. All these pilots, we have seen over the years that for large commercial and industrial prosumers, for the large ones, it's technically and economically viable. But for the residentials and also tertiary users, for example, buildings, it's still under development. And what we have seen also in the Hollister, and I come to that later, is that the technology is there, but the introduction of the business applications is slow. So what to do? What next? Come now to more details about it. And right away, I have here the conclusion of the paper and the presentation. In this Hollister project, in the work package on business innovation, we scrutinized all the products and services, the key exploitable results, and we came to the conclusion that they are not commercial interesting on their own. But if you add them to the regular service you already have, you get an add-on. You get some bonus, an extra, a small amount of money, more or less, because flexibility has value for people requesting for this flexibility. They want to solve problems in their network. I come to that also later. So it has some value, but it's small. But now, if we dedicate it to energy communities, then of course you have more flex to aggregate. And that the aggregation has value for the community as a whole. The community can grow as a business, and of course, energy communities. One of the driving forces are awareness and commitment in the group. These combined stacking, we call this stacking of services, can enlarge the awareness and commitment, and therefore. As we all know, the EU clean energy packages, they want to promote communities, in particular citizen communities, as entities on the market. These flexibility service as a cross value can add to the uptake of these communities, because they raises the awareness and the commitment of the community as a whole. That's the key point of this presentation. So let's go into, that was already the conclusion. The keywords I mentioned, flexibility. It's good to, if we want to understand this flexibility change, to understand there are two basic categories of flexibility. There is the implicit flexibility that, for example, is shown here, that a prosumer in the middle of the picture is served by the ESCO, the energy service company. The prosumers want to optimize their self-consumption, and generations towards the varying prices delivered by the supplier and the DSO. And the ESCO helps the prosumer, and the flexibility devices the consumer has are shown on the left-hand side, typically cooling, heating, electric vehicles, storage systems. So the aspect of the implicit flexibility, that the flexibility is triggered by price signals from market parties. The other category is the explicit demand side flexibility. Here, the aggregator in the middle of the picture aggregates. That's a new role on the market. He aggregates the flexibility of all the devices of prosumers of maybe a set of prosumers, for example, in an energy community. And this aggregated flexibility he offers as a service to requesting parties, market parties on the left. For example, the balance responsible parties, they have to optimize their portfolio. The typical network operators, they have the problems in the network congestion or all kinds of network constraints. They can use this flexibility, so they pay to the aggregator, and the aggregator shifts the value, the money back to the prosumer. And the last category, of course, the TSOs. They also want to maintain the balance on the high level network. So these are the flexibility. Now the Hollister project. I will not go in all details here, but typically Hollister worked on a holistic demand response optimization framework. It's a bunch of words, but typically we worked on an interoperability and data management framework, which is the heart of the Hollister system. And on basis of that, we have our tools as partners. And the nice thing about the Hollister framework is that you can combine these flexibility products and services, and they can easily be stacked onto each other, which makes them very useful for building up a flexibility portfolio for the energy parties. There were 4 different pilot sites in the Hollister project. Yesterday we heard the Serbia pilot was led by Belit, and also here on the bottom is the message from the business innovation part. These flexibility products are not that commercial interesting on their own, but if you can add them to your regular service, because they give insight, they have a small value extra to prosumers, they are interesting as a tool. Value stacking, I already used that word many times. What is value stacking? Value stacking is you bundle services, and in the flexibility, for the flexibility value chain, it means you want to enhance the economics of the investments. If you want, as a prosumer, want to offer flexibility, you have to invest in your smart devices. The devices has to be able to deliver this flexibility. And on the provider side, or the requesting parties, they also have to invest in ICT to gather this, absorb this flexibility. So stacking, bundling of these services is important to make it commercial interesting at all. Flexibility service can be stacked in 2 ways. The first is here mentioned. Aggregators can stack, bundle these flexibility service all together, so that they can address from one flexibility resource to more parties. The other way of stacking flexibility service, you have your regular service, and then you stack onto that the flexibility service, and that's what we call here cross value, and that's a bonus for prosumers, because then in that way, if we think about an ESCO, the prosumers can get more comfort, or optimize their operational costs. Now to the energy communities. I already told about the clean energy package that they want to promote the citizen energy communities as market parties. What does stacking here means? That the members can get more value, and that value that as an entity as a whole means that there is more commitment and more social cohesion. So it works in two ways. If there is cohesion, and then the community as a whole is more willing to use these stacked services, and on the way, if there are stacked services, it means a value for the community as a whole to grow as a business. And the community itself, of course, can also choose to act as an aggregator on itself, and then it comes into the flexibility value chain, and internally it can manage their self-consumption of the members and the generation. And then we come into the realm of the positive energy districts. One of the authors is also a member participating in the Smart City Project Positive, also was addressed already in this conference. And the flexibility can also be bundled together with peer-to-peer trading. You have to offer for yourself some flexibility, some energy, and for example, you can get some extra hours that you can enter a city for free, etc. That's another way of peer-to-peer trading.
George, I interrupt you briefly. You have 2 minutes left.
Okay, that's exactly good what I need. This is the overview of the community services. They have all kinds of services here. The community services, the yellow box, increasing energy awareness. The energy services around by the aggregator and the ESCO. And the stacking of the services, the blue box, there are the Hollister products, which we use as stacking onto the community services, the energy services. And the dash contour on the whole shows that the energy parts can play that themselves. So I now come to the conclusion. Happily, I already introduced that to you. So as an overview, flexibility projects are not commercially interesting on their own, but for energy communities, it can be very useful because of the value stacking, particularly the cross-value checking, and a good set of flexibility products could be the Hollister products because they can be combined, and it's an important driver for the clean energy package. So that brings me to the end of my presentation. Thanks.
Thank you very much, George, for this interesting presentation.
Thank you.
Do we have any questions from?
Not from the audience.
From the audience. I don't see anything yet in the chat. I have to get used to this a little bit, but maybe someone would like to ask questions.
No questions yet, Sylvia. We can proceed.
Okay, thanks. Okay.
We'll have a Q&A afterwards. So if something comes up, you can save your question for later on. So thank you, George, for this interesting presentation. And we move on to the next one by Meritxell Gomez-Omella. I hope I pronounced that sort of right, from TEKNIKER. And her presentation will be on lessons learned on electricity demand forecasting based on the RESPOND project. So please, I'll hand the floor to you, Meritxell.
Thank you, Sylvia, for the introduction. Good morning, everyone. My name is Meritxell Gomez. I'm working as a PhD researcher in TEKNIKER Foundation in Eibar, Spain. How can I get this out?
I think we see your slides.
Okay.
All set.
I'll continue. I would like to share with all of you our experience making short-term electrical demand forecasting in residential levels. This work was done in the context of the Respond AIDS 2020 project. Firstly, I'll explain you the objectives of the Respond project and TEKNIKER's contribution. And next, I'll introduce you the data available. Next, I list the methods that we tested to do the forecasts. And finally, I'll summarize the errors achieved and the lessons learned from this study. In the last years, the need for energy saving has increased. However, the demand response solutions are only being available for major users like industries. Respond is an Horizon 2020 project aiming to bring demand response solutions to neighborhoods across Europe. Some of its objectives include influence on the daily life habits of the users to change their consumption. Through these changes, reduce peaks on the demand for high energies, and those changes should be adapted, should be adjusted to the production to maximize exploitation of energy coming from renewable sources. One of the tasks in which TEKNIKER was involved consists of making forecasting of the energy demand as accurate as possible. And later, using the results, tips or suggestions will be obtained to provide users to modify their consumption. This presentation compares the effectiveness of different models using to forecast the electricity consumption. Well, the forecast study was done with data from houses located in 3 different sites: the Danish city of Aarhus, Aran Islands in Ireland, and the city of Madrid in Spain. We have 40 houses in total, and we have about 1 year of historical data for each house. Each file, its data from each house is stored in a different file. So there is different models are built for each house independently of the rest. The data sets are univariate time series containing values of electrical consumption in watt hours. The data are grouped hourly, so 24 points are equal to 1 day of historical data. And we observed a daily cyclical behavior in the data. There is lower values appears during the nights and high values of consumption appears during the day. But the average of the consumption remains constant over time. Despite the cyclical behaviors, there are some dates where some peaks of consumption appears in an apparently random way. Now I'm going to talk you about the methodology. There is the models that we test to forecast future values, and I'm going to show you a representative example of each model, but each method was tested for all the houses. The metric that we used to measure the error was the root mean square error. This metric calculates the difference between forecast values and actual observations, then squares them to avoid the cancellations in the sum, and then calculates the average. Finally, the square root is done to provide an error in the same units of measurements that as the original data. First models that we test were autoregressive integrate moving average time series models, ARIMA and SARIMA. First, these models fits or estimate future values using past values. So first, the parameters indicating the number of past values to use and the coefficients are estimated. And at the beginning, the results are good, but when we try to forecast more than 1 day ahead, the errors are added, and these models are not able to reproduce the good predictions. So we decided to train 3 of the most popular machine learning models. To train machine learning models, there are 5 steps are needed. First, understand the data. Apart from I've already mentioned about the data, the random component related to the user's lifestyle should be considered. The second step consists on creating features to train the models. We consider that the important information about the consumption can be given by the hour, the day, the month, the season of the year, the day of the week, and a binary variable indicating if this day is on working day or not. After we train linear regression, a supervector regression, and k-nearest neighbors. And we did at 10 days ahead forecasting. And in order to evaluate the accuracy of each model, we use the root mean square error as well. Some of machine learning algorithms calculate distances between instances to fit the parameters and to choose the information to use. And in our case, there are some input variables extracted from the time that have a cyclical behavior. For instance, the variable hour takes values between 0 and 23. So the Euclidean distance between 0 and 1 is 1, between 1 and 2 is 1, but the distance between 23 and 0 is 23. But we know that 23 and 0 are consecutive hours, so the distance between them should be the same as the distance between all pairs of consecutive values. And the same happened with the month variable. All distances between consecutive values are 1, except the distance between 12 and 1, that is 11. To avoid this fact, we propose to do a trigonometric transformation. For example, for the variable month has a period of 12, and we can divide the cycle, the unit cycle, in 12 equal parts, and each of the intersections between these parts and the cycle is one of the values of the month variable. And we can transform these values into the sum of cosine and sine using the Euler formula. So we obtain 2 variables from each of these variables. One is the sine of the month, and the other is the cosine. So after doing these transformations in the hour and month variable, we use these 8 features to train the machine learning models. So the first was linear regression. Linear regression tries to fit a linear relationship between the input variables and the output variable. It gave a high weight to the hour variable, but it copies patterns, similar patterns over time. So it is not able to capture peaks, and the errors achieved with linear regression are high. Using supervector regression, well, supervector regression fits better days from Monday to Friday in blue in the picture, but during the weekends it gave low values to the consumption, and in general it's not able to capture peaks. Also, in some cases, using supervector regression, we obtain negative values to the future consumption, and this is not possible because the consumptions cannot be negative. And finally, the best fit was obtained using the k-nearest neighbors. Although some peaks are not accurately forecast, there is it is a good model to use in the predictions of consumption. And well, if we compare the results obtained with each method, we can see that KNN can be used for this forecasting problem, because the errors achieved with this method are lower. The time spent to obtain the results is less than the supervector regression, for example. And using KNN, patterns are not repeated, and KNN avoids to give negative values, because the forecastings done with KNN are the average of other output variables, other output values in the historical data set. So if the training set contains only positive values, in no case the predictions can be negative.
Meritxell, sorry to interrupt you, but you have 2 minutes left. Is that okay?
Okay, I'm finishing. And well, that's the end of the presentation. So thank you for your attention. And if you have any questions, I can answer it now. Thank you.
Thank you very much. You were already concluding. I didn't realize that. Thank you for your presentation. Are there any questions or remarks from the audience?
Not yet, Sylvia.
Okay. I see no questions, right?
Correct.
No.
Correct. There are no
Cool.
questions yet.
Yes. There's so many windows in this program. It's I have to get used to it. As said, we can have a Q&A at the end. So I find myself having a question for George later on, but we'll keep that for later. So also for Meritxell, maybe people come up with questions or remarks. So please stay with us so that we can have this discussion later on. Our next presentation, Rosa Olivadese from the Dutch TNO as well, towards energy citizenship. I'll give you the floor, Rosa, and you can start your presentation.
Yes, thank you, Sylvia, for introducing me. I hope you can see my screen.
Yes, you can. If you can just put it in, yeah, there you go, thanks.
Yes. All right, perfect. Thank you very much, Steve, for introducing me, and thank you, Zia, for organizing this this event. I'm Rosamaria Olivadese. I'm scientist integrator at TNO, and I will share this presentation with my colleague from Demir Enerji, Beril. I will present first the first part, introducing a bit the topic, while Beril will focus on the 3 projects that we have analyzed: Smart City Project, Making City, Atelier, and Positive. And in this occasion, I will also like to thank the other colleagues, Jeroen, Beatrice, and Vicky, who has worked and have contributed to this paper and topic from the Atelier and Positive project. So as you all know, in the past years, and the Green Deal is just the last policy document that the European Commission has enhanced to foster the transition towards carbon neutrality in Europe. But all the things that these documents have in common is that citizens are put at the heart of the energy transition pathway. And the goal is to make is to have a fair and inclusive transition, making sure that no one is left behind. So this is crucial, and this is also and this is very strong, especially in the European Green Deal, where also that is also the base for the actual recovery plan that has been discussed in the past month in the European Commission with the member states. So what does this mean? This means that the energy transitions will require not only investments all across Europe for the technological development and business models and financing, but also it will require much more involvement of the relevant stakeholders, which are both private and public sector, but also the European citizens in the form of prosumers, energy traders, organization members, and participatory designs. And projections are indeed that by 2050, about 45% of the European households will produce their own renewable energy. So this is really a crucial topic also for upcoming year. How do we make this transition, and how do we make this transition inclusive? So the traditional market approach always have seen citizens as involved, really not involved in the energy production. So they were a bit more of a passive consumer, and individuals were seen as homo economicus, which means that they are only motivated in changing their behavior if presented with the right financial incentives. So and the process was more so a bottom-up approach. So you had a government, you had third parties, and you had citizens, and yeah, citizens were just a passive and user of energy. So to move towards energy citizenships, and we need to have a more multi-level and integrated approach. That means also having a new ecosystems where citizens become more active. They are involved and co-manage energy with the relevant stakeholders, with the government and third party. So this means moving from citizens and consumer towards energy citizens. And that means as well moving beyond individualistic approaches towards more inclusiveness and creating really the spaces for participation and engagement. The lower carbon communities are a place where this could take place. These are communities that can decide and act upon their own energy production and consumption, not only within the dwelling, but also with other dimensions of their lifestyles, which can be mobility or food consumption or free time lifestyle. And these low carbon communities can be different, can be place-based, can be linked to certain geographic boundaries, can be interest-based, and now, especially now, due to the COVID pandemic, digital communities are also growing. So there is a platform that is available that fosters the discussion and the engagement among the citizens. So really, to make this transition happen, cities are really the core and have a key role in making these transitions. And cities have to answer three main questions. The first is how to best harmonize and mainstream climate policy across sectors. The second is how to choose and integrate the low carbon technologies, but also how to ensure that citizens and business buy in. And if this does not happen, then the energy transition will be much more difficult. And until now, smart cities have been evaluated just within energy, mobility, ICT domains, but integrated sustainable urban planning is also important, because they is also important for an inclusive transition. Because this will take sustainable integrated urban planning takes into consideration also environmental, social, and economic aspects and the impact that a transformation can have on a city level or on a district level. So the transition towards energy citizenship takes place in cities, and one of the possible places is the positive energy districts. And what we have done in our research paper is to try to analyze three projects, smart city projects. They all work on the topic of positive energy district, but they approach this path towards energy citizenship in a very different way. So I would like now to give the floor to my colleague Beril to present each of these projects.
Yeah, thank you, Rosa. As Rosa explained, these are the three projects that we have been interested in this paper, and we have gone through these three use cases from the pioneer positive district projects of smart cities and community schools. For example, the other one, please, Rosa, not just the next one. I'll just summarize. For example, for Making City project, the focus is more on the citizen involvement and participatory design of the city vision and the pet co-designs. But on the other hand, for Atelier, the local energy markets as trading system for local communities are highlighted. And finally, for the positive market-based peer-to-peer energy trading platform is targeted. Next slide, please. And for Making City, Groningen, next slide, please. Rosa, I cannot see the next slide,
yes.
but so maybe, okay.
Is
now, yes.
Groningen? Yeah.
Now it's okay. Groningen and Oulu are the two lighthouse cities in Making City project, and the new shift in these paths, as Rosa explained, provide the new sharing mechanisms, and it's inevitable to empower citizens since they are gaining new and innovative roles than just being consumers. And Groningen's goal is to be carbon neutral by 2035. The city of Groningen has developed a district energy approach, and aligned with this vision, it's a very labor-intensive process. This approach seeks for opportunities with a fully bottom-up behavior, and it facilitates the groups of residents to do as much as their own as possible, and by the integration of the cooperative approach. Whereas the city of Oulu, for example, they built the community bridges, forums, and other joint events in the area where people can participate and interact with the public actors and other stakeholders as well. The aim is to reform services in municipal and resident-oriented and also customer-oriented manner. and it tries to have residents involved in planning and decision making concerning their residential area and the services around it. Next slide, please. And next slide, please, Rosa.
Yes, I think it takes some time to change
okay.
because it's
maybe my internet connection is a bit low. Okay, and for Atelier project, Amsterdam and Bilbao are acting as the two lighthouse cities, and an innovative distribution network is being established in these cities, and it will enable the effective and secure distribution and trading of the renewable energy flows over time. An innovative local energy market platform will be established to enable the virtual trading and sharing among the various projects in the PET. In Amsterdam, for example, a blockchain technology is introduced to trade energy via cryptocurrency. And also the first energy floating community is allowed to privately distribute, share and trade, because in their policies, actually the communities are not allowed to trade, but for this unique floating community, they have this permission. And this community is also running the local energy flows and manage the one-off connection with the public grid as well. Next slide, please. And for positive project, Alkmaar and Evora as being the lighthouse cities of positive project, and they highlight the importance of engaging citizens again for their voices to be heard and also become themselves as key stakeholders within the decision-making process. So it's a very collaborative governance process. One such solution to be incorporated with positive is the pilot areas. Is a peer-to-peer energy trading, to consider the pilot areas as a peer-to-peer energy trading platform. Peer-to-peer energy trading may then be perceived as a market-based community mechanism, and it acts really like behind the citizen energy communities. For example, at Evora, the peer-to-peer use case is implemented as a local market between selected buildings, and also rewarding citizens' sustainable investments and also their PV generation from solar plants in the surroundings of the positive energy blocks. And whereas at Alkmaar, for example, the P2P is also explored as a market-based community mechanism for the implementation of a city energy management system. In the system, the user and the owners of the buildings can buy or sell energy to each other and conduct flexibility in this manner. Smart charging and vehicle-to-grid systems are also being tested for electric vehicles, such as shared cars and buses. They will also be connected to this energy management system. So next slide, please. As a summary, each of the three projects described in this paper, they involve citizens in different ways. Like, for example, in Making City, it's mostly with the strong city visions that people recognize and value are the first step and for bringing the citizen on board. Bottom-up approach is used and on district level to create and share the knowledge and to develop district energy plans and PETs in cities of older Groningen. Whereas in Atelier, smart grids are owned by the community themselves, and they are allowed to distribute, share and trade rest, as I explained, with other entities and also in these communities. Lastly, for positive, the P2P, peer-to-peer energy trading platforms are developed to allow citizens to become key stakeholders within this decision-making processes, and it really empowers the citizens to feel in control of their own energy flexibility and valorize in a direct way, so they are directly involved in the system. And next slide, please, the last one. So lastly, we may say that there is really an enormous innovation potential of a combined approach towards physical energy transition investments and social engagement by participatory design, planning, and collaborative governance in the system. And I may say that by the help of smart city and communities projects and PET projects inside these calls, cities are exploring new policies towards energy citizenship. So the next steps for the energy citizenship could be the participation and engagement across various levels of scale. And the public interest is of energy citizenship, and is very important, and it legitimates the public action and public tools choices as well. And there is a claim of a quantified substantiation of the added value of the integrated planning in the system. So thank you very much, and if any questions, I don't know if it's so fast that we finalized in a fast way.
You're very well.
Well.
Thank you for this presentation, both of you. I'm looking at the audience to see if there's any questions. I do have a question, but I would like to give the floor to others first.
Sylvia, no questions from the audience. Feel free to ask yours.
Okay, well, thank you. I find it very interesting also that you combine the findings or the inquiries that are part of these 3 projects and the focus with these different but interconnected focal areas. And I think we're all a bit still searching what, for instance, peer-to-peer energy communities exactly are and according to whom, and what we all mean by these definitions, because there are broad general definitions about what peer-to-peer is, what an energy community is, also according to the European Commission, etc. But how it works in practice and what the different types of communities and peer-to-peer, how to say, configurations are, if you will, is still something that we're all sorting out, also to see how these community members can best be engaged, because I think in a lot of projects that still is quite a challenge. So my question is, you have a lot of very interesting material on pilots and on cases, and you made an overall comparison. Is that somewhere also gathered in a paper or in an overview so that others can take a look and see how you have done this and read a bit more in depth about this?
Okay, Rosa, may I start? And yeah,
yes, sure.
For example, making STIP project, it started end of 2018. It's almost 2 years now. But Atelier and Positive, they are newer projects. They are just 1 year old, let's say. And for Making City, we will be submitting the deliverables at the end of this year. So they may check our website to see the strategies that we are developing in the project. But for Positive and Atelier, they are, let's say, in the baby steps. So the things that we are presenting here are mostly in the theory, in the proposal stage, actually, but the results will be soon published in their websites as well. So okay, they are new projects. So we are also testing the results, let's say.
Yeah. Okay. Thank you. Rosa, you have anything to add? I know the Atelier. Yeah. When did the Atelier project start? When did the Atelier project start?
So Atelier and Positive are 2 sister projects that started last year. So it's they are now ending the first year of their activity, while Making Cities for the previous. So it's 2 years already. Indeed, there is still, let's say, not unified definition. And when preparing this presentation and the paper, we also had internally some discussions about it. Exactly what is the difference between, for example, a peer-to-peer platform and a local energy market? Because they can be maybe similar. They can be similar, but there are some differences. Otherwise, we wouldn't name them differently. And but we have seen indeed that there is still no clear definition. So I think all these projects have a very interesting point of view that could help in coming up with a common understanding. There might be some difference in how it is implemented, the implementation part. For example, that between local energy market and peer-to-peer platform.
Okay, thank you very much. It's it's a discussion to be continued, perhaps at the next Sustainable Places Conference, when we have all moved a bit further towards also more clear definition. Thank you both. And I propose that we move on to the next presentation. But I see that George Huitema has a remark. Is that the remark to the group or?
Yeah, Rosa already addressed that in the last remark. It's an ongoing discussion here, but because they already had 3 smart city projects, and of course there are many more. What can you say about what is missing here? It's only 3, and you could maybe see something what already is also interesting.
Rosa, can I invite you back to respond to this remark by George?
Yes, I'm not sure I understand correctly your question, George. Do you mean, can you maybe rephrase this question? Do you mean what is missing
to make it
in
too
terms
difficult,
of?
There are 3 smart city projects involved in this presentation. And of course, there are many more to be expected. What do you think would be a next thing to be interested in?
As topic, you mean?
Yeah.
Towards this? Yes. I think what we also mentioned in the presentation, like the knowledge that thing has to be, aside from coming up with a unified understanding and definition of peer-to-peer, of local energy markets and these kind of solutions, I think it's more focused in we need to pay more attention to make it as much as possible as an integrated process. And I still, for example, the experiences that when preparing this paper we had in the discussion we had with the colleagues from the other project was, yes, a lot of focus on the technical aspects, which are of course fundamental, but for example, the citizen part, it stays a bit on the side and tries to integrate, while what we mentioned, like what is the sustainable urban planning, but it's really more about integrated process from the start, which now, as we see also in Positive and Atelier, Atelier, for example, is a nice example because one of the districts is really it started from the citizens themselves, and they had some exceptions. It was allowed an exception in the Dutch law to share the electricity. So it's really about the trading of energy, but it really starts from the citizens themselves, and they try to understand with other stakeholders, with the public sector and the private sectors and energy providers, what was the best way to do it. And I think this is something that it's still to be investigated, still to be optimized. But maybe Beril, you also want to add something about it?
Good to know. Thanks.
I'm sorry, I connected for 2-3 minutes. Yeah, I think for the next step would be more exploring this issue, and if possible, we want to re-collaborate for a maybe new paper or an article. Let's see. But first, we need to see the results. I mean, in the next year and the other years as well, to make a good comparative analysis of these projects.
Okay, good.
I don't know if I missed another question, but it's just
good to know. Thanks.
I think your remarks made clear that what we see is when you refer, Rosa, to this integrated process that we aim at in these projects, I think it's also a matter of finding a shared jargon and shared definitions. Because, for instance, social scientists, they have scientific definition of peer-to-peer comes from a very different angle compared to the notion of peer-to-peer from ICT. And if you look at ICT and the area of energy, it sometimes only refers to assets that are connected in a network. when you look at the social sciences, peer-to-peer is about social groups that have some sort of a similarity, which makes them feel the feeling of belonging to the same group. So when we discuss peer-to-peer, some people maybe have in mind a network of assets that are interconnected, and some other people have a very sort of more fluid idea of people and groups that are interconnected, and whereby the connections are growing stronger or diminishing. And I think this also refers to the idea of sometimes you have citizen initiatives that really start from a citizen initiative in, say, a neighborhood, and sometimes, and that can be called an energy community, and sometimes energy community are discussed as if it's something that you can implement somewhere. And I think we're all searching like, well, what these are two, how do you say? They're on the bandwidth, like the two extremes, perhaps. So what does that mean for the definition and the practice of energy communities? This is a bit how I understand these discussions.
Yeah, I totally agree. I mean, when I joined the Making City and Smart City projects, I realized that 1 year ago, also the definition of positive energy district was still not clear to everybody, and everyone has its own nuances within the definition. So it took some time to arrive to let's say a common understanding of what it is. But I totally agree with you that these different sectors has different understanding of the terminology. But this is why then it is more and more important to work to get to have a multidisciplinary team to work on these topics. So technology is there. They have still some very big challenges to face. It's available, but if if in the working group there are no also, for example, the social science is not involved, people would probably have difficulty in understanding it. And if people don't understand the technology, they won't accept it, they will not implement it. And because now the Green Deal especially really push for an inclusive transition, for citizen engagement and citizen communities, this integral approach is really becoming more and more crucial. So I think we as a researcher, as an energy provider, we really have to work together with the different expertise to arrive to this common understanding.
Thank you. I may also add one last word. I really totally agree with Rosa, and we had this discussion just this week actually, because from also a social point of view, when you say P2P, and from economic point of view, you say local market, the local energy market. So it also has more or less the activities inside the terminology more or less the same. But when you use different terminology, then people cannot understand what is the difference between the different terminologies. For these three projects, for example, at the proposal stages of the projects, the terminology was not so clear, as also Rosa indicated for positive energy districts. So researchers try to investigate some terminologies while they wrote the proposals, and now since they are now testing the procedure and the terminology is growing, developing in this case. So we will see, I mean, in the following years, let's say, the exact numbers. We are testing them in the projects. So
yes, it's really a learning by doing.
Yes, indeed. This is what innovation is about. It means that the definitions are not set at the stage of proposal writing. And I think we all recognize this. So to be continued, this discussion. Thank you very much.
Thank you.
We move on to the next presentation by Ábel Magyari, if I pronounce it right. I practiced a week ago, but you will present about multidimensional evaluation framework for plus energy buildings and neighborhoods. I give the floor to you so you can further introduce yourself and your colleagues, please.
Thank you very much, Sylvia. Yes, I'm not sure. Do you see my screen only, or do you see this GoToWebinar panels as well?
I think we see your screen.
Okay, that's good. Okay,
that's what we need.
So my name is Ábel Magyari, and I am from AWUD, Advanced Building and Urban Design. This is an SME from Hungary, and I will talk about multidimensionality evaluation framework for buildings, for plus energy buildings and neighborhoods. I represent here the CET project, where our mission is to increase the share of sustainable neighborhoods with surplus renewable energy in Europe. Over the course of the next 4.5 years, we will create 4 real-life demos in different climatic zones in Europe. To be exact, 1 in Norway, 1 in the Netherlands, 1 in Austria, and 1 in Spain. The overall goal of the project and these 4 demos as well is to reach 100% energy savings, more than 90% renewable energy generation, 100% greenhouse gas emission reduction, and at least 10% life cycle cost reduction. As it has been mentioned earlier, this plus energy neighborhood definition itself is somewhat a contested term still. We are aware of the GPI definition, but the plus energy part, I think we need to talk about how we define it, the CET project. So we took the an existing plus energy building definition as a base, where they defined the plus energy building as a building that produces at least as many renewable energy as it consumes during a year when accounted at the source. And here source energy refers to the primary energy used to generate and deliver energy to the site. So CET used this definition and applied it to the neighborhood scale and to the neighborhood boundaries. And there is a change that in this definition applied to the neighborhood boundaries. It includes local storages and energy supply units, as well as the buildings and the microgrids and such. And these are all connected via a digital cloud hub. So in the CET project, we aim to reach different impacts, which are called the 5D impacts, namely decentralization, democracy, decarbonization, design, digitalization, and we aim to reach these impacts with our so-called 5S strategy: the save, shape, share, shine, and scale. As you can see on the left side, this is a really good representation of this. I will not talk about this in detail, but you can check out this on the CET website. I will show at the end where you might find this. What I will talk about right now is the evaluation framework that we created to evaluate these plus energy neighborhoods with a multidimensional approach, with the whole consortium involved. The leaders for this task was IREC, and we have them, and a lot of consortium members was also involved in this. So why exactly is multidimensionality needed? To evaluate the plus energy neighborhood is to evaluate the neighborhood itself is a multivariate problem, but evaluate the plus energy neighborhood is even more complex. So there will be strategies, as I mentioned earlier. There are a lot of strategies, and there are a lot of possible impacts that we aim to achieve. And it is not always straightforward that which strategy leads to which impact, and with which intervention we can influence which outcome. So we need to first and foremost we need to find these connections. Secondly, this is not just multivariate, this is a multi-level problem as well, because a neighborhood obviously consists of different buildings, different technical solutions. So we will have to deal with the problems arising at the building level first and foremost. Then we will need to look at the neighborhood level and its task environment and the problems arising at the neighborhood level. And obviously, when we scale up from building level to the neighborhood level, we will have naturally a bridging level that is more of an infrastructural level, but we will have problems arising at that level as well. And obviously, at the end, we will need to look at the European level, and we need to scale up from neighborhood level to European level, and need to look at the barriers and enablers on that level as well. So we will have problems from at least 4 different levels. And lastly, neighborhood level relates to a lot more stakeholders than for example the building level. So and an evaluation framework is good if it can cater the needs of every relevant stakeholders. So we needed to make sure that the needs and the possible impacts and the relevant let's say needs are taken care in the evaluation framework from all the relevant stakeholders. So what we did is first we defined what are the most important dimensions. For this, we took the 5D impacts, the main impact areas, main focus areas of the projects. We paired them with different strategies and different aspects and elements of these other frameworks. And we wanted to make sure that the dimensions incorporate all of these strategies, these impacts and such. So to simplify it, we wanted to make sure that every row is represented somewhere in the dimensions. And this way we came up with the 5 most important dimensions that we went with: energy and environmental dimensions, economic dimensions, indoor environmental quality, social, and smartness and flexibility. After this, we went with the following process. First, we collected an initial set of KPIs for every dimension. After that, we conducted multidimensionality analysis on the KPI set. We did this to possibly avoid the usual pitfalls that some framework fall into, and to avoid namely these errors, let's say, that for example, multicollinearity or the double counting problem, different biases, like for example, stakeholder bias and anchoring bias, and the over-reliance on different kinds and different types of data. So we did this with constructing directed acyclic causal graphs and as well as tagging tag-based data structure. Obviously, we set some thresholds on what how we define multidimensionality and when is the KPI set multidimensional enough, let's say. After this has been done, we revised the KPI set. We either subtracted or added different KPIs, and then we revised the KPI set. If it reached the threshold, we were good to go, but if it did not, we had to iterate it until it reached the predefined threshold. After that, we had our final KPI set. So it's really that simple. I will further elaborate on the second step here, and I will start with the causal directed acyclic graphs. So we did this in a way that we took the 5D impact areas, the 5D focus areas, and made them a central node, and then we collected every different KPI or possible, let's say, impacts that might influence these central focuses, central goals, and then we connected everything that might be connected in reality. So we wanted to map out the effects of different impacts around different goals on each other. And with this, we could eliminate collinearity, and we made sure that there is no over-reliance on one kind of data. The latter is pretty easy. We defined this as we wanted to make sure that there is no over-reliance on one kind of route, on one kind of data, with making sure that for every central goal there is at least 2 different, let's say, 2 arrows pointing from the outer nodes to the inner nodes, so we can reach the inner node with 2 different routes. And we did this for, and we also had a pretty insightful stuff that, for example, the energy consciousness might can be a great influence on personal safety via influencing sustainable mobility and then influencing personal safety. So it had really useful implementations. We did this for every different goal separately, and after this has been done, we combined these together to one big causal graph, and we actually did the multidimensionality analysis on this graph, but it's really hard to comprehend in such a short time, so I won't linger around with this too much. And so if we label the different set of KPIs according to their original dimensions, when looking at the goals, we get these figures. You can see that every different goal relates to at least 4 different dimensions, and you might see just by looking at that the decarbonization is maybe the least diverse dimensions because it has the most connections to energy and environmental KPIs, and maybe the most diverse is digitalization and decentralization, but really every different goal is spread across these different dimensions. Lastly, we conducted tag diversity analysis. As I said, that we took the KPI set and we tagged the KPI set along different logic structures. For example, domain of sustainability. This is something that you might know under the name of the 3 pillars of sustainability, so social, environmental, and economical. And I think most of them are self-explanatory. The 5D impacts we talk about. The authority is the one that may not be, because this is about stakeholders. So we looked at who does relates to different KPIs. So maybe users or facility managers and policy developers and such. So we tagged the individual KPIs and we wanted to see how diverse they are. So we used 2 different indices to look at this. Both are from the field of ecology. The first one is the Simpson index, which is a pretty straightforward index. It has values from 0 to 1. And 0 is the least diverse, 1 is the most diverse, yes, that's it. But the Shannon index is not that straightforward because it doesn't give you normalized values. It is used to compare different populations and diversity of different populations. Hence, we needed to iteratively find out what is the lowest possible value with these values that we have with these initial KPIs and tags. What is the lowest possible value and what is the highest possible value, hence the really odd scale starting from 3.58 and ending at 3.82. But the main takeaway here anyway is that all of these values are towards the final third of the scales, and since we defined our threshold in such a way, it was good enough for our threshold, so we could say that this KPI set is diverse enough. And just to end it, here is our resulting framework across 5 different dimensions: the energy and environmental performances, economic performance, smartness and flexibility, indoor environmental quality, and social performance. This whole work and this whole deliverable will be soon available on the CENICIA website as well. And just my final 2 slides. You can see here the whole consortium of the CENICIA project, and in the last slide you can see where you might reach us and where you can read more about the project if you're interested. So please don't hesitate to look these websites up and such. And thank you very much for your attention.
Thank you very much for a very comprehensive presentation with beautiful graphs, and also for mentioning that we can soon look more into this when this deliverable becomes available. Because I think, as with the previous presentation, we're all doing very interesting work in terms of finding definitions, doing inventories, but also developing evaluation frameworks. And it's only good if we don't do the same, if we don't reinvent the wheel over and again. So I think it's really interesting to further look at when this comes available. I'm also looking at our audience. Are there any questions or remarks from the audience?
Not yet, Sylvia.
No?
No.
Okay. Magyari, I think we have to sort of digest what you have presented. because it's quite a lot. We have a final Q&A, so if people come up with questions later, that's very welcome. For now, thank you very much.
Thank you very much.
I think we can move on to the next, which is, I didn't practice how to pronounce your name, Iker?
Yeah, Iker Esnaola.
Iker Esnaola from TEKNIKER, also, who will also present on artificial intelligence for cooperative demand response programs. The floor is yours. Please go ahead.
Okay, can you see my screen?
Yes, we can.
Yes, okay. Okay, well, thank you. Thank you, Sylvia. My name is Iker Esnaola-Gonzalez. I come from TEKNIKER in Spain, just like my colleague Meritxell, who made a presentation earlier. And I'm going to present the work named Artificial Intelligence for Cooperative Demand Response Programs in the Residential Sector, which has been done with my colleague Francisco Javier Diez, and also in collaboration with Dea Pujic, Marko Jelic, and Nikola Tomasevic from the Institute Mihailo Pupin in Serbia. Okay, so, well, I'm not going to introduce again the Respond project because, well, this work is also in the context of the same project that my colleague Meritxell explained. But just to make a brief summary, the goal of this project was to bring demand response programs to the residential sector in across in neighborhoods across Europe, and the other objectives were to reduce the demand peaks and also to maximize the exploitation of renewable energy. Okay, so to test that, we had 3 different pilot sites with 3 very different climates, 3 different types of buildings, consumption behavior, underlying energy systems. So there were 3 very disparate pilot sites in Denmark, in Aarhus, in Madrid, in Spain, and also the Aran Islands in Ireland. And well, for the success of our project, or the dispatching of energy efficiency actions, we developed a mobile app, which is essential to for engaging users to participate in these energy saving activities. And the app is available for Android and iOS. It's it's available in 3 different languages, and it enables the users to check their consumption, see how the neighbors consume, and receive notifications, and even make control actions. So let's see how the central artificial intelligence system that we developed to achieve these energy efficiency goals that I commented. So this is the overview of this artificial intelligence system, and we have 4 different blocks. We have the measurement block, the forecasting block, then we have the optimization block, and finally we have the control block. Now I'll explain how some details of these 4 blocks. I won't go into much detail because it can end up being a little bit too technical, and we are writing an article in this regard. But anyway, the idea is that the interaction of these 4 blocks enable achieving these energy efficiency goals that we have. So the first block, the measurement block. Here, what we did was gather or collect the information coming from different sources. Okay, information related to the energy consumption of the users, the ambient temperatures, the weather conditions, energy prices, all the relevant information for the upcoming blocks. Okay, we had two different smart home solutions. We had two providers within the project, which were Develco and Energomonitor. We also developed an energy gateway, which is based on the OpenMOOC, to retrieve information from devices that were not from Develco or Energomonitor, from legacy systems, let's put it that way. And we had three different repositories to store the data, because we had data of different characteristics. So, for example, for the IoT data, or the data coming from the devices, we had a time series database, which is an InfluxDB. For more, let's say, static data, like the buildings where the devices are installed, and all this kind of more static data, we used a triple store or an RDF store, which was an OpenLink Virtuoso. And then we also had a relational database. In this case was MySQL, to store other data, like, for example, the predictions that we made. Okay, so that was the first block. The second block is the forecasting block, which, using this measurement, we developed two different services: a production forecasting service and a demand forecasting service. So the production forecasting service was in charge of estimating the production, or the energy to be produced for the upcoming 24 hours by the systems that were installed in each pilot site. Each pilot site had its own renewable energy sources. So, for example, in August and in the Aran Islands, we have PV panels, and in Madrid we have a solar thermal collector. So in this case, the idea is to estimate how much energy these systems are going to produce in the upcoming 24 hours. For that purpose, we developed data-driven models for the PV panels in Denmark and the solar thermal collector in Spain, using random forest and neural networks. And for the PV panels in the Aran Islands, we had to resort to a physical model, because we didn't have enough historical data. That was one of the services of the forecasting block. The other service of the forecasting block is the demand forecasting service. Okay, the goal of this service was to estimate which is going to be the energy consumption of a whole neighborhood for the next 24 hours. Just like Meritxell explained earlier, we chose the KNN algorithm, and on top of that, we, let's say, developed a variant of this KNN algorithm using patterns instead of features. Well, the interesting thing here is that, due to the coronavirus situation and all the confinement measures, especially in Spain, which were quite strict in comparison with the Aran Islands and with Aarhus in Denmark. The behavior of the users changed drastically. Their energy consumption patterns changed. So we had to deal with the so-called concept drift, and we had to develop different models and different strategies to try to adapt and still continue making accurate forecasts. Then the third block is the optimization profile, which uses both the production and demand forecasting from the previous block, and it also receives external information such as demand response events and also the energy prices, and it produces the optimal demand curve, the curve that we should follow to achieve this energy efficiency, energy stability goals that we have. So in this case, the optimization block, it's based on the Energy Hub optimization model. It uses the information that we generated in the previous block, the information of the estimate of the energy to be produced by the renewable sources and the energy to be consumed by the users. And it also considers, as I said, the external factors like energy prices and the demand response constraints that can be set. And it's adapted to the configuration of each pilot site. As I said, we have 3 different pilot sites, so we had to adapt to their configuration. Well, the idea is that the users are supposed to display the flexibility proportional to their demand, and the optimizer uses the demand flexibility to propose shifting loads. Okay, the total energy consumption remains the same, but the thing is that certain demand periods are shifted to other better periods of time to avoid these energy demand peaks and also exploit better the available energy, produced energy coming from the renewable sources. Okay, and finally we have the control block where we need to somehow translate this optimal curve into actions. I mean, what do we need to do to achieve this optimal curve? Well, there are 2 different types of actions. In this case, we have automatic control actions where the user doesn't need to implement anything, and also manual actions. These manual actions can be controlled remotely by the Respond app if it's possible, and if not, the user will receive a notification in their mobile phones just to implement this action. So, for example, here we have a message where there is a PV panel over production, and it suggests to activate the dishwasher. So the user could do that with the mobile app. And apart from that, inside the control block also we implemented a heuristic optimization model so that, taking into account the user preferences regarding when they want or they could activate or use their appliances, this model proposes the optimal time or time period of time when the user should use their appliances, of course, towards the achievement of this optimal profile that was produced by the previous optimization block. Okay, so this is the whole central artificial intelligence system, and now let's see very briefly how we implemented it in one of the 3 pilot sites. In this case, we selected the pilot site of Aarhus in Denmark. Here we had 20 social houses participating in the project. The renewable energy sources were the PV panels, which were installed, where they were communitary for the whole neighborhood. And here we had both electrical and thermal consumption. We worked on both energies, electric and thermal. However, for this use case, this example, we are only going to focus on the electrical consumption. So once we collect all the information from the measurement block, we would be here in the forecasting block, where we had on the left side, which is the consumption of the whole neighborhood for the next 24 hours, and also here, well, on the right side, we have the energy to be produced by the PV panels during the next 24 hours. So we have these 2 information, which are used as input for the optimal profile. And if we look at the charts, we can see here how in the afternoon it's foreseen that a demand peak is going to be produced. So it would be interesting to lower this afternoon peak. And on the contrary, on the right side, we can see how a little bit earlier there is going to be a overproduction or a very big production of energy coming from the PV panels. So it would be interesting to also try to maximize the use of or the exploitation of this energy. So as I said, these two informations are used as input for the optimization block, and the optimization block proposes which would be the optimal demand curve. So as we can see here, taking into account the overproduction or the very big production of renewable energy, the optimal profile would try to raise the consumption. So it says that the optimal demand curve would be to consume a little bit more here and consume less here, taking into account that this demand peak should be reduced. So here we can see that the optimal curve would be a little bit more stable. And of course, how are we going to achieve this optimal curve? We need the users to participate. In this case, because in this pilot site we had, for the electrical part, we had only manual control actions. So in this case, the user would receive a notification in their mobile app saying that they should try to use more energy in this period of time and less here, with specific actions. Okay, so here, for example, it says that they should activate the dishwasher, for example. And conclusions. Well, as I said, I just explained it very briefly and at a high level because I didn't want to go into much detail and end up being too technical talk. So this is the way we have achieved the energy efficiency goals that we had for the demand response project. We developed an artificial intelligence for the problem that we have, which is a complex multi-objective problem because we are dealing with neighborhoods, individual users, their consumption from their appliances, etc. So it's a complex multi-objective problem, and we achieved that by the interaction of these 4 blocks that I mentioned: the measurement block, forecasting block, optimization block, and the control block. And that's all from my side. And if you have any question, I would be happy to try to answer them.
Iker, this is the sorry.
Yes.
Sorry,
Please
Sylvia.
go ahead, Zia.
Okay. Thanks. So, Iker, there are several questions from 2 people in the audience, Christina and Daniel. Christina and Daniel, I'm going to unmute you. If you could please try and keep it succinct, that would be wonderful. So first, Christina, you are self-muted. If you unmute yourself, you should be able to speak. There she goes. I see you're unmuted, Christina.
Can you hear me?
Yes, we can hear you.
Sorry, I had a problem. I selected the wrong microphone. Anyway, I actually have a couple of questions. The first one is about one of the databases you mentioned, the relational one, the third one, and I would like to know a little more about it and if and how and if possible it is connected to the other 2 databases.
Yeah. So the thing of we are using. Let me show you the overall picture. So here the measurements, we normally get them from the IoT devices. So we are using the InfluxDB because it's optimized for this kind of information. However, for the results that are produced in the forecasting service or the demand service that are going to be used later on by the optimization service, we store them in the relational database because I mean, we are making the forecast once a day, and it's not, let's say, real data, so it doesn't make a lot of sense to store it in the InfluxDB. So that's why we are using the MySQL in this case for this kind of information.
Okay. Thank you very much. The second question, very briefly, is that if you have the chance to check if the users followed the suggestion you gave them through the hub.
Yeah, so well, I didn't mention that the Respond project finished officially last month. So yeah, we already have all the results and everything. Yeah, the user engagement is it's a very difficult thing. Of course, users install their app and everything, but they prefer to receive the notifications by other means. So in this case, so for example, when the electricity price was for free or was at very low rates, we used the WhatsApp messages to send them this information. They were participating, but if information was coming through the mobile app, they didn't use it that much. Okay. So yeah, I mean the user engagement.
Sorry.
Yeah, sorry.
So you try to find other ways to engage them.
Yeah. Yeah.
Okay.
I mean, in this case where we had manual control actions, we needed the users to participate. Otherwise, we wouldn't achieve that. So yeah, we paid special attention to the engagement, which I think it's one of the most difficult things, especially in the residential sector, because for the user, I mean, from an economic point of view, it's not very motivational for the user to follow these orders because they won't save up that much. So you try to find other ways.
Yes, I fully agree. Thank you for your.
Thank you. Thank you.
Thank you, Christina. Next up from the audience, we have Daniel Carbonell. Go ahead, Daniel.
Yeah, hi. So I'm Daniel from SPF, the Institute for Solar Technology in Switzerland. One of the questions has been already answered. I mean, how was the participation of the end users in these suggestions? But I think you answered this, so we can go ahead. Another question was if you have compared different machine learning methods, or the neural networks was a clear decision or a choice from the beginning.
No, you are referring to the
forecasting.
Forecasting of the production, right? So this one, right?
Mm-hmm.
Yeah. Well, we tested different methods, and the best ones were these two ones: the random forest for the PV panels, and the neural networks for the solar thermal collectors that we had in Madrid.
Why do you think you need different methods? I mean, the PV production and the solar thermal production is, I mean, it's not fundamentally different.
Yeah, but the thing is that for the PV panels, well, this part was done by our colleagues in Serbia, so maybe they could give you more detail. But the thing is that they apart from the data sources that you use for these two are not exactly the same. So of course the solar radiation it's common in the two cases, but for the PV panels they used additional variables to make the prediction of the energy to be produced. I cannot tell you right now. I mean, I can email you just for you to know which are these variables and why they selected this, but
yeah, maybe I will contact you for this. Yeah, thanks.
Yeah, Daniel, you can contact Sustainable Places at r2msolution.com and we'll connect those dots for you. Thanks for the questions.
Okay. Thank you.
Okay, thank you. If there are no more questions, we move to the next speaker. Thank you very much, Iker.
Thank you.
What Zia just said, it goes for all. We are not allowed to share email addresses, but if you like to get in touch let Zia know, and he can provide you with the email address. Anna, is it you or is it René who's presenting? Because I didn't see you yet in the audience.
Yes, it's
list.
Anna. She's here.
Oh, great. So Anna will present on the CVPP project. Anna is from the Technical University Eindhoven in the Netherlands. And Anna, if you're ready, I'll give you the floor.
Yes, I'm ready. Thank you very much, Sylvia. My name is Anna Wieczorek. I'm with the School of Innovation Sciences in Eindhoven. I am a sustainability transition scholar, founding member of the network, actually. What I would like to present about is energy communities for energy transition. And in particular, I would like to give some insights from CVPP project. I think I'm not sharing my camera. I think that will be much easier for people, perfect. Right? I'm sorry. So insights from the CVPP project. This project has been funded by the Interreg Northwest Europe. And on this slide, you see all the partners. It's a truly co-creative and transdisciplinary project with different contributions from municipalities, cooperatives, private sector, researchers, but also a DSO. And we also work with the USEF Foundation. I would like to make 3 points in this talk. The first one is that the energy system is already in transition. I would like to argue that CVPP, a community-based virtual power plant, could serve as a potential accelerator of this process. And at the end, I would like to discuss possible roles for energy communities. So talking about definitions, we also found it very important to clarify what we are talking about. An energy transition is on lips of almost everyone. I would like to explain how we see energy transition, and it's based on research for about last 20 years. We see an energy transition as a radical change of the current way through which we provide energy system to a new one. There is an ongoing discussion about how this new system should look like, but there seems to be some emerging consensus that it has to be more decarbonized, and I think research in this session also showed it, more renewable based, more digitalized, more participatory, maybe more democratic. But these systems are extremely difficult to change because they are stabilized on a number of dimensions. So when we talk about a radical change, it's not only about replacing of technology, but it is also about changing policy, our practices, markets, users, a number of dimensions. And these things do not happen just like that. There has to be a good interplay of a variety of forces. One is coming from broader contextual developments, such as digitalization processes. The COVID-19 is also such a broad type of process that can destabilize the current systems. And on the other hand, there also has to be availability of alternative ways through which we would provide our energy needs. And through these interplay of these processes, these current systems, even though they are very stable, they can destabilize and these alternatives can take over. Now, I showed this picture to clarify not only that what we mean by energy transition, but also to say that understanding of the broader context is extremely important to talk about our contribution from a bottom up and from our particular projects. I also want to say that energy transition is really about different way of organizing our system, and that this energy transition is already unfolding. But some say it's probably not going fast enough. So there are many conferences about acceleration of energy transition. And I think it was also mentioned that we today that we are focusing really too much on technological innovations, that we look on the production side, on efficiency. You observe also quite a dominance of established large companies. And all these community energy initiatives, they mushroom, they pop up, but they sort of miss critical mass. And additionally, the incentives to be active on the markets are not terribly large. So then virtual power plant sort of emerges as an alternative that can challenge the current system through which we provide our needs, and it can serve as an accelerator. And what you see on this picture is how we have provided our energy needs for quite some time, really based on centralized fossil fuel based of production. The electricity has been transported to our homes through the transmission network and distribution network. But I think this is this picture shows better what is right now happening. Increasingly, people, communities, but also utilities are deploying renewable energy, and that causes bidirectional flows in the grid. And when you add to this an intermittent character of the renewables, then of course you can imagine there are problems in the grid, because electricity is such a medium that has to be matched, demand and supply has to be matched in the real time. So grid operators are looking for potential ways to deal with these problems. And of course, they can put thicker cables in the ground, they can modify infrastructure, but they also think about aggregation of distributed energy sources in a form of virtual power plants to deal with these sort of congestion and balance problems in the grid. So virtual power plant is nothing else than a sort of an ICT platform, a software-based solution, which aggregates all these distributed energy resources. So demand response, generation, and storage. And because all these elements act together with each other, then it can be seen as a single entity. And that's why we talk about power plant. But because it's not in one place, is distributed, we call it a virtual power plant. And through virtual power plants, new roles sort of emerge in the electricity system, away from only consumption and production towards also management and trading. Now, when we were starting the project, we wanted to see whether we are doing something novel, and we composed a database of different projects that looked like virtual power plants, and we found out that there are quite many. They are deployed at different geographical levels, quite many in the Netherlands, but they were mostly initiated in this very top-down way by TSOs and DSOs. Really with a purpose to deal with the issues in the grid. And you can imagine then the prosumers were in some places, depending on the country, selectively recompensated, but they did not really have any decisive power in saying, yeah, how much of energy, at what time, in which markets. So these needs were really assumed as individual and really driven by finances. And when you think about communities and some prosumers, they don't think in the first place about dealing with the congestion or balancing in the grid. They're ideologically driven. They want to do something good for the environment. They want to participate in the energy transition. They want to gain some independence from the system. They want to have some self-consumption, maybe lower electricity bill, but not dealing with the bigger problems of the system. So in this project, we simply got to think about how can we conceptualize, develop, and also test a virtual power plant that is serving the system at large, but that is also taking these community aspects seriously into account. So we spent quite some time in the beginning on discussing what is it that we mean community-based virtual power plant. We knew that this is a sort of a social technical innovation, that this is way more a social innovation than technical actually. And in the discussion, it came very clear that we have to understand what we mean by community. And this community is also operating in a very certain regulatory context, which makes some things more possible and some other less possible. And only then we can talk about, okay, so how do we schedule these virtual power plants in a way that it does what the community wants and can in the given context. So that's how we got to the necessity to clarify what we mean by the community, and was also discussed today. We were asked whether two people is a community, whether a street would be a community. But based on a very systematic literature review, and also based on the insights from projects, talking to people, revising all the European definitions, we came to conclusion that this is not so much about how many people, is it two or more, but it's about the community logic. So if you talk about a project, it is a community project when it is truly driven by the people and by their needs and by their motivations, and that these people decide that they have the decisive power about how they organize themselves, how they own assets, how they engage its members, how they deal with people, for example, in a village who don't have possibilities or funds to be included in this. So it's up to the people who get together to organize themselves and decide what is it that they are doing together. Now the winter package is being translated right now. It defines very specifically different types of communities, and one of the requirements is that they have to be legal entities. So I think this legal entity is something that we also have to add to this definition. So based on the work that we have carried out, we have came up with a very generic definition of a community-based virtual power plant, which is generic, but at the same time it allows to take into account this context specificity and specificity of the given community, because the community can be of different type. It can be located in one place, but not necessarily. It can be distributed. But what's important is that it is deciding about themselves, and that it follows this community logic. It's also important that there's already some VPP related assets, such as distributed generation, controllable loads, storage. It can be just one of them, a combination of two or three, but it's important that you have some assets. And once these things are sort of clarified, then we can talk about how we want to schedule the whole operation of this enterprise. And then we talk about an EMS system, energy management system, a platform which is connecting with the prices, with markets, with the weather, and is steering the demand response in a way that the community really wants. And through this type of CVPP configuration, communities can play different roles in the market. So we use the family resemblance principle. This is to say that there are many different communities. They are organized in a different way. They have different needs and motivations, but they are all part of one family of CVPP. And here I come to the pictures that also George showed in his presentation. From USEF. We also worked with them. USEF is actually one of our partners. And right now, in terms of playing in the market for prosumers and especially communities, the situation is not so great, because we are practically operating in a very fixed price and fixed tariff type of individual configuration. In the Netherlands, we have a day and night variation, but that's probably about it. So it feels sometimes as if we are pushing with what we are doing with CVPP, we are pushing water up the hill. It's very difficult, but we very much hope that this winter package will soon be translated. We are participating in preparing the input to the stakeholder consultation about its translation in the Netherlands and in Belgium. But we hope that once this is translated and it seriously gives communities space, then we worked with USEF to prepare this picture, which is a sort of next step in considering the flexibility value chain. And this side is what George was talking about, this explicit value chain where prosumers individually or as a consumer can provide the flexibility to different parties for different purposes, congestion, balancing, portfolio optimization. But there is also this implicit value chain where the communities can share energy. They can also share flexibility, do peer-to-peer, different types of flexibility services. And we use this picture also to discuss what type of roles these communities can play in the future energy market. Depending on the skills available in the communities, they can, for example, do what the ESCO is doing for them now themselves. They can do what the facilitator does for them. They can also become an aggregator. They can become a supplier. This is the case in Ireland. If they have some microgrid in their possession, like in Brainport in the Netherlands, they can also play a role of the DSO. So everything is really, many things are really possible. I don't know how to go next to my next slide. So in this project, we have implemented and we have tested this concept of community-based virtual power plant and the different roles in 3 different locations, different communities, also rural, social, and dispersed, and also in different countries. So different social, economic, and regulatory context. We tested this broad design. And we have also developed what Sylvia will talk about, a mobilization and replication model to help new communities who are interested in this type of aggregation to think about now, what are our problems? Is energy an issue? Is CVPP something that can help us solve these problems? And I think when we talk about the energy transition in this project, we have shown that it works. It works technically and it also works socially, because what happened in all the processes in all these countries was that before we really scheduled the technology, it took us really a number of months to set the social process in place. And only then we could talk about how we put all the technology together and how does the algorithm for this EMS system looks like. So it works not only for the system, but for the community as well. So it is a sort of a win-win solution that really empowers the prosumers. On our website, you can find a lot of information. We have also webinars. We have a lot of prospects, policy briefs, documents. So I invite you to take a look, and thank you very much for listening.
Thank you, Anna, for your presentation. Do we have any questions? I see George has a question.
I see. So what is the commercial potential of CVPP? Do you think that stacking of cells is necessary? I think I want to say that I really love your value stacking concept. And I think indeed communities do not do this because they want to earn money. There is also, they want to keep their community aspects. And of course, when you look at the current system, it requires large volumes, it requires professionalization. And communities don't want to go that far. They have totally different values, but this flexibility, playing flexibility card for me is just putting a foot in the door to make a claim that, you know, they can matter. Now, I'm now with the students calculating how much of this flexibility is available and how serious it is. So for now, I cannot answer whether there is a commercial value as such, but maybe after half a year, I will have some specific numbers for you.
Okay. That's clear, Anna. We are also struggling with the same exercises. The flexibility is there, but what is really the value and how many aggregators will be there in each country? And your concept of the community-based VPP is very interesting. So it could add some value, extra value here for the communities. But we are still struggling with, as a prosumer, it's not enough. But if you combine it as an aggregator does, then at a certain point it becomes commercial interesting as a whole. And
Yes.
and maybe we have to, if we want to push communities, we have to push communities on that side. But of course, we don't want to have them as a commercial part already have. They have their own values as communities.
Sure.
So yeah, it's interesting to see how this develops.
Yeah, so we are now, we finished the first round of the project. We got some funds to continue. And in the second round, we are going away from replication, so doing more of the same, towards discussing upscaling and the best models for upscaling. Because exactly what you say, we realized that if single CVPP grows in size, which you need for the current setup, then it loses its sort of community element. But maybe if you aggregate CVPPs, so you think of a different architecture, then maybe you can keep actually both. But that's something we are going to figure out in the coming year or two.
Yeah, maybe next year we have a presentation of that.
Yes.
Good, thank you, Anna.
Okay.
Thank you.
Thank you very much, both of you. And indeed, we'll have to keep up with the further developments, which will also depend on how European policy is going to be translated, I think, to the national context, which is, we're still in a state of absolute flux in that sense. I have a presentation coming up now, which builds on what Anna has been presenting. I just press the timer so that my alarm clock will go when my time is up. And then I have to check if you can see my screen.
Yes, we can.
Let me see.
Perfect.
I suppose you can see my screen, and if not, Zia, you will tell me, right?
Correct. You're all set.
Okay, I'm all set. So, yeah, my name is Sylvia Breukers. I actually forgot to introduce myself when we started. I'm from DuneWorks, which is a small research and advisory company based in the Netherlands, in Eindhoven. We do social scientific research on the energy transition, basically, in a variety of projects. And one of our projects that we have been working on for the past couple of years is a community-based virtual power plant project. Anna gave a very nice introduction to the project and an overview also of the overall findings. The presentation that I'd like to share with you is based on the work that we've been doing. And by we, I also like to refer to Luc van Summeren, who's doing a PhD at the Technical University of Eindhoven. We've been working to develop an approach, a model, if you will, to help advisors, process moderators, to explore with the community if a CVPP is a good idea for them. I will tell you about this approach, which we have also tried out and tested with 6 replication communities in the Netherlands and Belgium. And furthermore, I'd like to say that the pictures and the cartoons that I will use have been drawn by Luc as well. So I'll give a brief introduction. I'll walk you through this mobilization and replication model, which is this approach that I just mentioned. I'll highlight some of our experiences with the replication community that use this model. And I point out towards some next steps, like what does this model bring us? The MORE model, as I said, it's an approach for process moderators who want to support energy communities to explore what's possible. And these process moderators, just to clarify whom we are talking about, they can be members of an energy cooperative who are very active within their community. They can also be part of intermediary organizations that are specialized in supporting energy communities. In the Netherlands, there's various organizations who offer support in energy community building, so they could also be a user of this model, or any other enthusiast or professional involved in energy community building. This model is not designed for people who do not have any clue yet what they would like to do. So if you have a group of citizens that are thinking about perhaps doing something with solar power, that's not the main target group. It's those communities that already have done something. Neighborhoods that have already installed a lot of solar PV, and where the question is coming up, like, how can we actually use the self-generated energy ourselves, or what should we do with the surplus, or can we store this energy, or what else can we do? So that is important to mention, that that is the target group of the MORE model. And I would like to show you a brief animation that is developed also to show to energy communities. And I hope that I can now share my other screen, which is a Prezi presentation. Can you see this?
Yes, indeed.
Okay. So this actually is a very short introduction of the mobilization and replication model for potentially interested users. So what is to start with then, because community-based virtual power plant is not on top of everyone's mind. So what are we talking about? And this is the explanation that we have developed. Basically, until recently, the citizens' role could be best characterized as passive consumers, consuming electricity bought from suppliers. These passive consumers increasingly become prosumers who actively invest in and become owners of renewables, either individually or collectively as part of an energy community. Novel technologies like batteries, energy management systems, in turn enable these prosumers to become smart prosumers who manage electricity and demand and supply within the household. This can also be done collectively by means of a community-based virtual power plant, which enables energy communities to manage energy demand and supply within their community and to trade energy and flexibility. This is a brief presentation within like a few minutes that already gives a quite clear idea for people who are actively engaged in an energy cooperative, for instance, but who are not familiar with the concept of virtual power plant or community-based virtual power plant. So this is a explanation that works quite well in practice. Then, of course, why a virtual power plant? Well, a very simple explanation. It can help the collaboration with the larger energy system actors, because this is what it looks like now. All these individual households, if we combine, if we move together in a single entity, this makes this interaction much more simple. But then why a community-based virtual power plant? Or if a CVPP is the answer, what was the question? And here we list all sorts of questions that come up within current energy initiatives that a CVPP can help solve. For instance, how can we keep self-generated renewable energy within our community? How can we support the matching of supply and demand of the energy network? How can we contribute to a more sustainable and just energy system? Or better understand the challenges of the energy transition so that we can decide how we want to participate? Is it possible for households without any investment power or without any suitable roofs to still participate in the community energy initiative? And what if we generate more energy than we need ourselves? Can we sell it on the market? Can I share or sell the surplus energy generated with my solar panels too, or with my neighbors? Sorry. So these are questions that do not include any jargon, but that point towards what a CVPP could bring as an answer to these questions. And how to further then explore that? Well, for that we have developed this mobilization and replication model, which is for energy communities to explore the possibilities of a CVPP for them. And this model consists of 3 elements, if you will. It's a process support tool, which includes several tools as well as content. And I'll go briefly, into that. The process, and this is, we have tried this with the replication community, consists of 8 steps of interactive backcasting to co-create desired future stories. And just a brief introduction to backcasting. Backcasting is a proven method that is very useful for innovation processes, because unlike forecasting, which projects the current situation into the future, backcasting starts from an imagined future, something that is not yet possible now fully, but that we would like to reach. So it's helpful to invite people to think out of the box and to consider then what is needed to arrive in that future. So interactive backcasting starts with the co-creation of that desirable future, and then the participants look backwards. That's also relevant because a CVPP can take many forms. It's not one single blueprint type of solution. It can take many forms in terms of how it's organized, the technologies involved, how it fits with the already existing situation, in terms of how it can engage or will engage the community and how that may change over time, and in terms of how the CVPP enables activities and goals that the community actually values. And so this interactive backcasting exercise can help a process moderator to co-create this ideal together with the participants. We have several steps, as you can see. If you tilt your head a little bit, you can see all the steps. And when you go through these steps with the community, where at first there's a very vague idea about we would like to do something with our self-generated energy, at the end, a more contextualized future vision is created, which reflects the actual situation on the ground of a community. And it also then helps to point out how the decisions of today will impact the feasibility of that future. So even if we don't know yet if we will reach that future, we can still keep it in mind, and that may affect our choices today. And that's exactly what this process is intended to support and accomplish. So this is the process that we went through with these communities. And to be able to do that, we developed several tools and templates that provide support to create content, to create ideas in a structured manner, and also to analyze in between the ideas that have been generated and to translate it into a story and feed it back to the community to discuss this, to design a timeline where we also can clarify what, if we have this ideal but yet feasible future image, what is it that we need to do on a longer term, and then looking backwards, what are the steps that are ahead of us for the coming years. And then it becomes more clear how the pathway towards the CVPP could look like. And then we also have very important content. CVPP and actually the whole change in our energy system that also CVPP represents in a way is we go beyond generating renewable energy. We go beyond efficiency and saving only. It means that a lot of complexity is confronted. We are confronted with a lot of complexity, and supporting community initiatives to deal with this complexity can be done using crash courses. So we have developed crash courses that address what is a CVPP, how can we understand the background of how our energy system of today has come about, what about policies, what is energy flexibility, what energy market roles are there, and what about community engagement, how should we go about that. So this is a summary of the MORE model, as we also presented to process moderators that might be interested. I am switching back to my PowerPoint slides. Just I think you can see it now. If not, you will interrupt me. So what we've done, in January, we had a first workshop with replication community. Oh, my alarm clock is, so I have 2 minutes left. I'll try to be brief. We had a first live meeting with 3 Belgian initiatives to start this backcasting process. After that first meeting, we could no longer have any live meetings due to the COVID-19 situation. And that was actually quite a challenge, because with the Belgians, we had already met the community members, and we had worked with them, and we had gotten a feeling of their enthusiasm about further exploring this CVPP. With the Dutch communities, we didn't have a first physical meeting, so we had to do it all online, and that posed some challenges. Nevertheless, we managed to go through this process. So this is the backcasting process in a linear way, and above you can see that we had 3 meetings with each community online for the most part, and the steps underneath the steps, you can also see sort of in between outputs that we produced using the tools that we developed. What was the value of this MORE process for the participating communities? Well, it helped them to structure the issues, to structure what they actually want, to get also an idea what they already have within their community in terms of technologies, engaged participants, how they make use of policies, future policies that they would like to use, make use of. But some of the tools in this exercise help to reduce options. There are many ways in which you can think of as a VPP project within your neighborhood, say, and this process helps you in a structured way to consider what do we want to accomplish, what goals and values are important for us, which activities belong or should help us to enable these, to create this value if you want, and what does that mean for how the CVPP is to be configured. And then you see that the options will be reduced. It also provided them with a perspective for the short, middle and long term, and especially the short term is important. We clarified sort of actionable questions that they, the community members could pick up and sort out themselves or together, because we also try to build a network of these communities that will help them to make first start. We also generated, as I said, outputs in between these workshops. And when we now take a look at all the outputs that we've generated, and for instance, the challenges that they see, we see similarity across all these 6 communities. And I would just briefly, we haven't gone in depth into this yet, but just briefly highlight some of the questions that they had. In terms of physical and technological challenges that came up were very concrete. What are the no regret questions for our initiatives, and how do we get to gain insight in these? So if we have, if we're going to have more electric vehicles, battery storage, charging poles, how do these take into account a possible future CVPP situation whereby we want to be able to move the electricity in 2 directions? Because a lot of charging poles currently don't allow that yet. But also, as for policy, there's of course a lot of questions. What's the future of net metering? What about peer-to-peer? How is this EU policy going to be translated? How to move on in this state of uncertainty? What about the short and longer term financiability of this type of project? How is that related to the new policies, but also to opportunities to become a pilot in an EU project like this Interreg project, or like in one of the projects that part of the audience today is also involved in? But also internally, what sort of investment can we reasonably ask from our community members, which has been pointed out before by George, considering the uncertainty also in terms of the returns that we can expect. How to engage the broader community beyond the enthusiastic initiators of the first hour. and other, what scale should we become? Should we seek to become feasible but still be community-based? This is something that Anna also pointed out. And also a question like, who are we as an energy community? Are and will we remain a group of enthusiastic volunteers? Do we want to become a professional player? Do we want to move, when we're successful here, do we want to try to do the same thing elsewhere? And how will that affect the role that we take? But for us, when we use the MORE model with the communities, the most important question that all communities still had, and I think this is a question we don't have a direct answer to. We had a lot of advice and suggestions, of course, but even for energy community initiatives and initiators within these energy communities, there is still the question how to engage the broader community and membership of our initiative. And I'm sure the continuation of the CVPP project will also shed some light on how to go about this and how the different suggestions that we made work out in practice. And indeed, the next steps, what we hope is, well, soon our MORE model will become available online in a matter of weeks. So, and it's a freely available tool, of course, in the public domain. Within the CVPP project, the replication communities that participated, some of them will be supported to further implement the CVPP within their community, but also having and being involved in other projects. The MORE model gives us insight, and also some of the outcomes will be useful to use in other projects to support energy communities that aim to move beyond generation and saving and efficiency. And as such, it's a tool that's not only focused towards bringing people to develop a CVPP, but to also inquire what would be possible for us as an energy community. And as such, it's an interesting tool because it starts from the idea of the community-based values and goals that are relevant. Thank you for your attention. You can contact us if you like some more information. Are there any questions?
Yes, George has a question, and there's also a question from the audience. So before George, let me ask from Michaela Dudita. Can you please give one or two examples of no regret questions?
It's
Yes.
not me, but
but
it's a good question.
No, it's for Sylvia, I believe.
Yeah. So I'll first go into the no regret option. Well, what we found out was that when communities, for instance, decide if they want to invest in heat pumps, and they are considering what sort of heat pumps do we want to have, and do we want heat pumps with these storage vessels, then these no regret questions that came up as a result of looking at the future CVPP was, well, can these heat pumps and these storage vessels play a role in when we want to offer some flexibility in the future? And what does that mean for the exact type of heat pump that we want? And if we want information on that, what where do we go? Because it's been an experience of the implementing partners that sometimes the installers don't even know answers to these questions. So then you have to go to the producers of these heat pumps. So these are the type of no regret questions that came up along the way. Also questions like, if we have other appliances, what should we take into account when we purchase them, when we want them to be controllable in the future by an EMS, and what are the additional costs that brings? So because we had the experience with one of the implementing partners that to make an appliance, I don't remember which appliance, controllable from a distance, it added up to the cost later on. Is this an answer to your question?
Let me unmute Michaela, and then she also has, or he, I don't know, also has a second question. So Michaela, you're unmuted if you want to go ahead.
Yes, thank you for your answers. That was fine. I especially like the example with the heat pumps because we are also dealing in the 3HP project with new heat pumps and with the consumer's acceptance. So that's a large topic. Another question that I would have: how can the initial enthusiasm can be maintained? Because we know many people, they have initially a lot of enthusiasm, but after that they lose very quickly.
Yes. Well, the first enthusiasts that we had in these community initiatives, they have been involved in the respective energy initiatives already for quite a while, but they all face sometimes the stress that they do it partially voluntary in evening hours. So it's a very important question how to keep them engaged. What we discussed with them is that it's important to start soon with engaging, finding other enthusiasts to broaden the membership of those members that really want to take an active role, search for ambassadors, but also to sometimes the municipality, for instance, can provide some subsidies to, for instance, in the Netherlands, there are subsidies for neighborhood initiatives in view of the transitioning away from natural gas, whereby part of the process of engaging the broader community is receiving some funding, so that those who are active no longer are purely voluntary, but also can receive a salary. And I think municipalities can play a very important role in that. And within the CPP project, we also had, they were called energy directors, but it's a wrong translation, but some sort of paid energy ambassadors and coaches at the neighborhood level. So you have to broaden the base of the front runners, and you have to seek for subsidies, because at some point, these initiators also get questions like, how can I become a professional in what I'm doing here? And that's a good thing.
Thank you very much,
Thanks.
Sylvia.
Thanks, Michaela. So the final question for you, Sylvia, comes from George.
No, actually, I didn't send in a question this time.
Oh,
my
I
mistake.
don't know which question are you addressing, because
No, I saw some. What is commercial potential of CVBP?
oh, that
think
was
that's
already.
It was answered.
Yeah.
Okay. There are actually and there's another one from Daniel Carbonell. Oh no, it was just nothing. Okay, so we can move on to Simona. Thanks, everybody.
Thank you, Simona. As I see it now, because our final speaker won't show up, so Simona, you have the floor for the final presentation. Simona Doka from Huygen Engineers, and you will tell us some more about the Energy to Peers project. Please, the floor is yours.
Thank you so much, Sylvia, for introducing, and I'm glad to be at the end of this very interesting panel. I think there has been a carousel of incredibly interesting insights. I assume you can see me, you can see my screen, so if I don't hear you any further, I'll just continue. So I'm here today to present the Horizon 2020 Energy to Peers project towards a new generation of peer-to-peer local energy community in Europe. So let me just see how I can move. Oh no, I want to leave the webinar. Let's see, okay, perfect. So my name is Simona Doka. I'm the Horizon, I'm the Energy to Peers project coordinator, and I work for Huygen Engineers and Consultants in the Netherlands. So again, today I am introducing this new project that has been started just recently, 2 months ago in September 2020. So per se, we don't really have a lot of results to present, but definitely an introduction of the scope of the project, and interesting how this will entail with several projects and activities that have been presented during this panel, and also resonating with some of the concepts that have been mentioned today. Okay, perfect. So indeed, the Energy to Peers project is a coordination and support action. So we really like to intend this as a collaborative effort among 15 European partners. We do have a very multidisciplinary team. I have to say, I think at least in our experience, this is unprecedented because we managed to connect several research institutes, also having several and different backgrounds. We do have social scientists, we do have anthropologists, but we also have communities. For instance, the Skånskip community, which is a organization of residents in Amsterdam that decided to self-organize into an energy community. But also software providers and universities all together, working with municipalities and social housing providers and private sector. So also very important presence of the private and public sector together, working together. So this is a very multidisciplinary and collaborative effort, and will last over the next 3 years. So where all this started, I'm very glad of having here today some keywords that I really hope these are not buzzwords on the lips of everyone, but key concepts that are resonating and hopefully will move forward in the next period. So we know for instance, from opening statement in the European Parliament of our new President of the European Commission, Ursula von der Leyen, that we have a sort of revised scope for Europe to become the first climate neutral continent in the world by 2050. And of course, this entails investment in technologies. But even just with this new technologies, the goal that we're targeting of reducing emissions by 40% by 2030, it's not enough. So it's very clear that a new engagement comes from the citizens. So this new role of the European citizens is strongly advised. And so the price of the change needs to be paid by everyone, and it's through behavioral change. That's very clear. And the way we are going to do this, this new role for European citizens and this new target is reached by this fair and inclusive energy transition as well. So this concept of leaving no one behind and offering perspective. So this keywords of leaving no one behind and offering perspective is also the core approach in Energy to Peers, where it is, to use some words that I borrow from Sylvia, also because DuneWorks is present in Energy to Peers. It's really a mobilization and replication model where we learn from existing and present experiences with the energy communities, and specifically peer-to-peer realities, learning from this and trying to mobilize experiences in Europe. So when we talk about European energy communities, of course, we still see several barriers, and I am glad that today we stress this concept that of course there are several experiences in Europe, and all this experience is using a different term. So I really would like to excuse everyone if there is still a little clarity also in the term that we want to use within Energy to Peers, because we just set up our environment, and we are debating internally also which are the better terms, the better glossary that we want to use internally for our project. What we know, and it's our clear and main overarching challenge, is that the concept of energy community, it's still not completely clear yet for most of the stakeholders. And within the concept of energy community, we can mention, at least for the scope of Energy to Peers, local energy communities, peer-to-peer, but also peer-to-community and peer-to-market. So one of the first objectives within Energy to Peers will be to clarify all these concepts, or at least to try to clarify this concept by learning from the multidisciplinary team. So in a sort of co-creation process as well. One of the main obstacles for the uptake of energy communities in general, not only in Europe, is the users' understanding and acceptance of this, the key element, which are the collective actions that are needed to intrinsically build energy communities within this concept of energy transition. So understanding what are the collective actions needed and the benefits of undertaking these actions. And of course, the third key overarching challenge is that there is the need for clear guidance, education, and support with respect to the methodologies and the current practices for the setup and for the successful uptake of energy communities, both at the local level, so the member state level, and the European level, because of course there is a sort of boundary and between what can be achieved at the member state level and what has to be achieved at the Commission level. So these are for us the three overarching challenges, and it's sort of manifested and we bring with us. So what we are trying to achieve in Energy to Peers is it's quite relevant, and I'd like to go through this concept one by one. So first of all is to deploy user-friendliness and attractiveness, reflecting the smart dimension of the community. So we've heard from the presentations before that these smart dimension of the community, the social engagement is extremely important, and that's the reason why within the consortium we engaged experts with background in social science and in anthropologies, that together with the rest of the group will build up this strategy to overcome the barriers, at least from the social perspective, how to make this energy transitions as inclusive as possible, user-friendly and attractive. Of course, energy communities, being them peer-to-peer, peer-to-community, peer-to-market, must be cost-effective and reliable. So the work will be to work towards the reinforcement of these elements together with the technological partners, of course. Energy communities and peer-to-peer energy communities especially must fulfill the concept of self-sufficiency and interactiveness with the grid, but also being able to resolve problems such as access to the grid, grid reluctance, and reluctance of customers entering on the network, because of course the benefit and the aversion against losses. A very important element that we recognize within Energy to Peers is the compliance with the European member state legislations, because despite the fact their willingness and the acceptance of the community could be reached, there might be still some barriers under the legislative aspects that will lock in basically in just a certain mechanisms against, for instance, others that might be more favorable depending on the type of community we're working on. And of course, support the decision making, which is absolutely relevant in this case. So generally speaking, the objective is to support the co-creation with the team. So and the co-creation with the communities. So being very specific in this case at the local level, bringing with us this holistic and user-centered approach where these solutions are again co-created with the community and together with the experts and their multidisciplinary background. Our objective is to reach out minimum 10,000 residential customers within a wide range of stakeholders, and I'll show you the communities we're working on. We have several communities in Europe, and to finally demonstrate that collectively organized peer-to-peer energy related actions are financially viable. So also working with interesting and dynamic financial schemes and different business models that will be tested at the regional level with several stakeholders in these pilot communities. And importantly, engage with municipalities, engage with the European interest groups. And in this case, we managed to engage both private and public European interest groups, so social housing and property owners organizations. A key element in Energy to Peers is to address what we call a readiness framework. So a peer-to-peer readiness framework. And we have here three main pillars of readiness that we would like to understand. So the readiness of the community to adapt to the capacity and the needs of the users themselves. So like the user perspective. The readiness to facilitate maintenance and efficient operation at the community level. So here is the operational level. And the readiness to adapt the peer-to-peer mechanism in response to the local situation of the energy grid. So these three elements are have to be seen in a holistic way, cooperating and reinforcing each other. The final outcome of Energy to Peers, one of the final outcomes of Energy to Peers, will be this peer-to-peer readiness framework with 5 indicators. So as Sylvia mentioned in your presentation before, we will study existing solutions, we will learn from different expertise, and we will create a framework that will be embedded in the platform. I'll show you after, to be able to assess for any energy community, for any peer-to-peer energy community, the level of readiness depending on different type of indicators. So how the organization, so the organizational readiness, how the organizational asset is ready to uptake to a peer-to-peer concept. Institutional readiness, so there we have all the legal boundaries, so the barriers and the legal perspective, if it's feasible or not to uptake a local energy community to peer-to-peer mechanisms. Market readiness, of course, how the markets at local level is ready. Technological, we know all the technology, and of course users readiness, so the community readiness, the trust among the community. So each of these elements will be developed, assessed, and we'll be developing a tool that will allow to assess under the different indicators how the community is ready to uptake to the peer-to-peer concept. Here is this a screenshot basically of the overall structure of the Energy to Peers platform, which will be a gamified platform at 3 levels. to support the peer-to-peer mechanisms. In very shortly, the level 1 will be the level of the platform that will assess the peer-to-peer readiness level. So in this case, we are targeting policy and decision makers whenever they want to evaluate the possibility to uptake a community to peer-to-peer concepts. And there we will measure or assess the readiness based on carousel concepts of measures that has to be included within the community, based on these 5 indicators that I just showed you before. Level 2 will assess the optimized operational performance. So the core of the platform will be a platform previously developed by our partners, our technological partners, and basically will be a part of the platform tailored to energy efficiency service providers, operators that could use the platform to straightforwardly monitor the optimized performance from the peer-to-peer platform. And then level 3 of the platform will be tailored towards the customers of and the users of the platform itself and the members of the community, being them just users or prosumers or active producers only. So there, the outcome will be an open data secure API in which all the data will be stored, and we will support the constant engagement, also connecting to a comment before we had from the audience, managing the constant engagement of the users over time. We will be using gamified features. Of course, this is not a game, but the gamified aspects means maintaining the level of engagement high with badges, with nudges, with prompts tailored towards the different audience with different languages. The energy to peers demonstrators, the concept of leaving no one behind. So we have this, let's say, mobilization and replication model, if we want to borrow this term from Sylvia. So we will start observing the initiators and the innovators in Europe, where peer-to-peer energy communities are already existing and running, which is in this case Schoonscape Energy Community in Amsterdam. We have a strong engagement from this community, and together with them we will move to the what we call the early adopters. So we have 4 energy communities always in the Netherlands, Into the Wood community, De Heuvel, Hoogdalem and Woerden. They're all in the Netherlands, and with these examples we will basically teach, learn, and perfuse lessons in the early majority. So basically existing energy communities that would like to uptake to the peer-to-peer concept, but still have some barriers. So we have the community in Spain and one in Slovenia. And then we'll finally move to what we call the laggards communities. So a situation in which the energy communities do not exist. There are basically there is a community of buildings, there are neighbors, but there is a high potential replication like in Italy, especially because we know there are several incentives to support the renovation wave in connection to the uptake of local energy communities. So they would like to move to the right hand side of our Gaussian curve and also connect to these laggard communities, which represents large majority in Europe as well. So this is the end of the presentation. Of course, I am not able to present any results at the moment, but please stay connected. Our website will be online soon, and for any need, just send me an email, and I'll be able to and happy to connect with you. So thank you very much.
Thank you very much, Simona, for your presentation. Are there any questions or remarks for Simona?
No, not at this time. Thank you.
Okay. And we thought we didn't see Philippe, the final presenter, but he has joined the group, and so we can actually then move on to our final presentation by Philippe Galvez from Engie about digital platforms for energy. And I think Philippe is there. So Philippe, can I give you the floor? Zia, do you can you see if?
Yeah, he's coming. And your
Okay.
webcam, Philippe.
Webcam not working, so it's just.
That's fine. And Simona, you can turn yours off if you'd like.
And now I restart GoToMeeting every time, so I have the. I don't know what is happening on the Mac, so sorry for that. So sorry for the delay, because I was thinking to come at 12, because I was thinking that I am the last presenter, so sorry, I was in another meeting. So thank you for your time. Thank you for giving us the opportunity to present. I will be very brief. I don't want to take too much time on your time. I will present Platoon. I will make my screen full screen. I hope it works. Yes. So Platoon is a H2020 project. I am the coordinator of Platoon. It just started in early this year, and Platoon stands for Digital Platform Analytic Tools for Energy. So I will present it, and what is important for this project, or it can help a community, especially along the energy value chain, and what can the other interesting partner can provide to Platoon or participate to the Platoon ecosystem. So about Platoon specific objective, what could bring Platoon for energy communities and sustainable places, and concluding remarks. That is a project overview. So Platoon is basically a big project. It's a 3-year project with 20 partners. You have the list of the partners in the slide, in 9 European countries. And it just started on the 3rd January 2020. And it's very interesting project because it follows other projects that we did at Engie around energy, interoperability, big data, machine learning, and so on. And so what's the context? I mean, everybody knows the context, but there is the electricity is moving from a central approach to the decentralized and decarbonized one. There is, renewable energy sources coming everywhere, so wind turbine, PV, and so on, and you need to use all those data to be able to perform or to optimize the use of these assets. And that's become very important. And if you look at different initiatives in Europe, Gaia-X, European data space, and so on, using the data in an efficient way, that's something that you need to be able to do, and it's not so easy. So what are the global goals of Platoon? So we want first to be able to extract knowledge from data and be able to share this knowledge and the different representation of this knowledge when it comes to energy sector. We will build new business models, mostly because like many H2020 projects, I don't say that our will be better, but we will develop a marketplace. So it will rely on specific, let's say, technical bricks that will support this marketplace. So Platoon is more, it's not another platform, it's more an ecosystem. It means you can use Platoon with your own tools or your own platform or your own ecosystem, because Platoon is focusing very, very strongly on interoperability. That's probably one of the most important things in the Platoon, and the way that you transfer data and you use the data. So it will be COSMAC compliant. That's a requirement from EU Commission, and we expect, or we hope to contribute to the standards for energy management systems. So this is a pilot in France for building. So you have different type of pilot. You have one for big assets, I would say predictive maintenance of wind farms in Belgium with the University of Brussels and Engie as well. We are working, there is several pilots around building. So when you are in sustainable place, building play a big part of it, and especially they are part of energy community. So you have some pilot in France, pilot in Spain, as well in Italy with Roma Capita and Post Italian. So we have a bunch of pilots around these things. Of course, we have pilots around smart grid, energy management system, electricity balance in Serbia, and predictive maintenance. So there is multiple type of pilot along the energy value chain, and we will test the ecosystem of Platoon in those different pilots. So if there is one slide that is important to take with you from Platoon, is probably this one. That's three main pillars of Platoon. First, we will work strongly on interoperability. One of the things that the EU Commission is trying to do is to develop this European data space. Means that there is in Europe many data set, data place, data space, but most of them are not interoperable. You can exchange in an easy way data, and you don't have the same representation, the same definitions. That becomes quite complicated. So we will rely on what we call semantic data model, and we try to develop representation of the data that we will find in the pilot. This representation, a semantic data model, will be open source. They will be displayed online, and partners can use it to build some tools. That's the first pilot. The second one is data governance and security. Once you have described your data, that's wonderful, but you need to be able to exchange your data between different type of roles of actors in a secure way and respecting the digital sovereignty of your data. And for this, we will rely as well very strongly on a well-known now framework, which is IDS, supported by Fraunhofer. And IDS is as well a very important technical brick from Gaia-X. So it enables people or entities to share data between entities in a secure way. So once we have described the data and the models, we will use this to transfer the data. And at the end, once you have these two main pillars, you have our data analytic toolbox that will be basically services, algorithm models that we will run using the data that are sent to them in a secure way and in the same representation. So concretely, when you saw the different pilots, there is many pilots around building efficiency in energy in the building and so on in Spain, in France, in Italy. So one of the things that we can do is each pilot will develop some tools, some analytic tools based on their data that they have, but they can open those data in a secure way to other provider, can be concurrent, and this concurrent will use the different representations that are shared, the container to share the data, and they will apply their own models on the data of another participant. And in this global value chain, let's say around data, you secure the data, you use the same representation, and you can exchange like services that will be deployed at the end on the marketplace. So there is many challenge that we try to tackle, especially when you look at renewable energy sources in Europe. So you need to, some of them are here, but there is others. So you need to very focus on electricity balancing at different levels. There is to have a holistic energy vision, especially when you come to dispatch optimization. So there is, we will not do everything, but we try at least to have a good representation of some of the use case or challenges that can rise in our pilots and contribute, put one brick in the system to enable this transformation and evolution towards renewable energy sources and ecological transition. So what it brings perhaps for you, if you're interested, you can contact me. Platoon for Energy Communities of our Sustainable Place. We will provide soon, it means in 2021, a global ecosystem, tools and open interfaces that you can use in your environment or in our environment to develop new services, to describe new type of data, to enrich the semantic data models, to try to start to build services that use IDS to transfer data and so on. That's the first thing. One of the things that it can be interesting for you as well is that we will launch 2 open calls. It means that we will sponsor with money some participants that are very accurate. We have a strong filter process to identify these actors, but we are focusing on startup and SMEs. And these startup and SMEs will get some help. They will get some money, but they will get some help, data, expertise, and so on to build new services using the Platoon ecosystem for different use cases. But if they can focus on the different pilots that I just mentioned before, it will be great. And it's already building like a communities around Platoon. So the January 2021, we will launch the first open call, and there will be another one coming. So you can contact me. There is a website and so on. But I think it's interesting if you are inclined to work in this direction. So we are cooperating with many other partners, IDS, of course, Industrial Data Space, Bridge, which is a very large initiative to connect all the lot of H2020 projects. We are a member of BDVA as well. Next week there is a big conference on BDVA, and we are connecting with other initiatives as well. So, and especially Gaia-X and European Data Space. So that's it. If you have any question, you can connect. So website is under maintenance, but we have a website, we have a LinkedIn. Soon we will display some webinar on the Platoon, especially to support the open calls. And we have Twitter like everybody. So that's it. So if you have any question or remarks, I am available. So thank you very much for your time. And
thank you very much. And I think there's a question, eh? I think Magyari has a question.
Yeah, sure.
Can you unmute? Yeah, please.
So thank you very much. It's a really interesting presentation. I was just wondering that if I understood it correctly, in this marketplace in the future, data could be shared and data could be bought by others from certain projects, and it will be shared only with the algorithms made by others, and algorithms can learn from data, but the data won't be shared per se. Am I correct?
Data, they need to be shared, because if you don't have the data in some way, but they will share it using the IDS framework. It means they will be containerized with a secure systems, and for specific purpose that you need to describe why you want to use this kind of data and what type of data, and explaining perhaps in a secure way what type of data you are expecting in your algorithm or models in your service. But data will be shared between partners. It will not stay in somewhere in the marketplace. Of course, you can imagine that's another step, that data is embedded in some, let's say, web app container and so on. You deploy as well your model in the web app container, and this interact directly without the different container, but without sending the data in some legacy system somewhere, and you don't know what is happening and so on. That's another possibility. We need to look at it. I don't know if we will able to do it, but it will be very interesting, I think. Like having agents that are able to interact, agents and provide data, agents and provide some service, they interact together, but in a secure way.
Okay, then the other question of mine is not valid, because I wanted to ask that whether there is a data curation process, or how do you validate that the data is really that they claim to be.
Okay, yeah, all right, thank you. Thank you. What kind of business application are you considering? So, yeah, for us, I would say for our pilot for Engie, we want to deploy some services that will enable a better, let's say, monitoring, optimizing of building. It's one of the use cases that we have. We have many other use cases, but that's the first one. The second one is around wind turbine, predictive maintenance of wind turbine. So we are focusing now on specific, let's say, anomaly set of wind turbine, and we will try to go for the full use case. And at the end, you have a service that are able to address this kind of anomaly for specific part of a wind turbine, and it will use a representation of this data. And once you get this data from another provider, you can apply your services. I know that Technalia is working on digital twins and so on. That's another one. We have this pilot around smart grid, energy community that we do with Politecnico, or that Spain is doing. So we have many topic around smart grid and energy community, so we will develop some specific services. So there is many use case and business case. Of course, it's a research project, but at the end, ENGIE is a company, so we need to make money. So I hope we are able to translate this concept in a real use case, and the marketplace will be probably a place where you have this kind of service that can generate value and business.
Okay, there was a question from my side, George. I understand you will consider several use cases, but the intention overall is to make a generic interoperability platform of architecture. So in essence, you want to address all possible business applications what we can think of in the future.
Yeah, we want to provide this ecosystem that rely very strongly on what we call the interoperability layer, so at least to interact with different systems, because you will never, I think it's my position, I don't think you can go with your complete platform and you go in a provider, in a company, or I don't know, a city and so on, you say, hey, look, I need to deploy all my platform if you want that the thing is working. That is, I don't think it's worked like this anymore. So you need to be able to have some, let's say, an interoperable layer that connect different parts of your system. And once you come with the ecosystem of platform, perhaps you will have, let's say, the analytic toolbox will be used, perhaps the aggregating or IoT connector with the API for specific part will be used, but you deploy some things that match your context or your environment. And once you have this, we have this kind of few pilot. We have, let's say, low level, we have use case, it's, I don't know, probably 15 use case, that for 3 for one pilot, to 4 for another one, and so on. And we try to demonstrate the whole pipeline. It means describing your data in an interoperable way that you have in your pilot, pushing like a representation, this semantic data models, that's the SAREF, the SEAS, all these ontologies that you have outside and so on. There is already something outside. Then you look, if you are able to grab the data from the asset or from the technical part, you get it, you transform or match with your semantic representation. And once you have this, at the end, you have developed like your tools, optimization tools to optimize, I don't know, the use of the different boiler, HVAC, and so on in your building, and you apply these services to the data that you receive. And if you want to send the service or use the service in another context, you can do it as well, because you use the same representation of the data that you need to optimize an edge HVAC, for example. That's more like the big idea.
Thanks. And on the other hand, there are also other projects designing these interoperability platforms, etc. What is your positioning amidst these other developments? What is the unique value?
Yeah, that's a really good question. So first, I am quite convinced, but it's my personal position from a coordinator, but we need to discuss that if you don't share representation, this interoperable representation, the representation of data or your knowledge models, let's say, you will never build the communities that use it and it becomes the standards. So once with this SEAS project, that's now part of the SAREF, the interoperability model, yeah, we didn't succeed to build this community. So first, you need to have this, say, open source representation that connect some knowledge model to another one and so on. That's the first one. You need as well to have a pipeline that are able to grab data, transform it in this representation, and be able to use it. And I think we have very good partners to do this. That's another issue that is not so easy, especially if you look at data will move from, mostly it will come back to the edge, or it will be very edge oriented. Data will stay at the edge, will be processed at the edge, will be infer reasoning at the edge, and so on. So you need to be able to query some system without taking the data, but querying directly on the fly and using this in transforming in an interoperable way on the fly. So that's something that I think we can bring to the thing. And the last one is yeah, the data mark effects that everybody is doing, yeah, providing some service that can auto-describe themselves. So based on the data and the functionality of your model, you make let's say a automatic description interoperable that other service can look for you automatically, machine, and be able to know what kind of data you use or what you need, and request those data and the model, semantic model linked, let's say in automatic way. But perhaps it's too far, I don't know, but that's something we try. And one of the things that we try to bring as well is you have the ecosystem, but you're supposed to be, we hope we can do it, you can take models from the ecosystems, for example, curation, the query system, and so on, and connect in an easy way with Open API to other systems. That's another thing.
Thank you, Phil. Yep.
Thank you both. I see that there's another question from Valerie, so maybe you can ask it yourself and also put on your webcam to, even if
it's from the audience. So go ahead, Valerie.
No webcam, but yes, my question is, my name is Beril from CET. So my question was if you know if it exists a similar project, but dedicated to heat rather than electricity, like your project seems focused on.
You mean district heating cooling, something like this?
Yes, yes.
Yeah.
Because there is also a lot of interesting data that can be shared, and well,
we don't have this in the scope of our project, but let's say, and I understand that you are from CET, that we're supposed to push a project together soon that have this focusing on it, let's say, and perhaps to look at this and around building and district heating, cooling, and so on. So yeah, there is probably people outside that already describe, let's say, I hope, I don't know, in a semantic way or in an interoperable way, the knowledge domain of it. So perhaps something.
Okay, so I look forward to discuss this with you.
Thank you.
And then I see that George is asking what is the name of that project. So maybe there it comes. There is an answer. But yeah, so Zia has typed the answer to all.
Yeah,
I put in there's just a few DHC projects. Go ahead.
No, the project is just a proposal that we just made. So I cannot too elaborate on this, but one of this is with the CET as well. But yeah, there is already many projects around district heating cooling, and I think that's a good question. But in the pilots that we have, and something it could be interesting to have some partners in the open core that are working in this type of environment, district heating cooling, and they want to use Platoon for developing some use case around district heating cooling. I think it could be great.
Yeah, I also would like to join these conversations.
Yeah.
Okay, thank you. As said, you can, if you don't have each other's emails, please contact Zia. I would like to invite all the presenters to turn on their webcam to start the closing Q&A. So that we can all see and remember the interesting presentations that we have heard today. So to the audience and also to the presenters, does anyone have another question he or she would like to ask? Or a remark? George, yes.
There was an interesting discussion also on the KPIs or a presentation from Magyari. Yeah, sorry for not pronouncing it well. But you gave a complete overview of all these KPIs and all these dimensions, etc. Actually, in the Making City project and also in Positive, we have to deal with all these KPIs and quantify them. And then the problem starts, because then you have all kinds of dimensions and units. And do you think upfront, when you categorize all these KPIs, how to calculate or to make because otherwise you have different you estimate soft and hard KPIs in a different way, and at the end you should come up with one general result. Do you think also on the implementation side of it?
Yes, we are not quite there. I think we will follow up with this work with different papers and such, but for sure normalization and weightings of these KPIs are a really big challenge, and I don't exactly know how to do this, because for now a lot of possible solutions are still in conversations to like for this multi-objective optimization, like to find these Pareto optimal solutions, and yeah, so I think I know what you are talking about, but we are still not there yet. But I think we will. We are currently working on this, on how to aggregate these KPIs, and how to come up with a value that is understandable by different stakeholders, and it's easily comparable, because yeah, as you said, that we need to find the optimal number of values that can be compared between different demo cases.
Yeah. Yes, because it's a real struggle at the moment. The more KPIs you have, the more problems you have when you have tried to make real calculations on that, because the buildings have different units and the boundaries. For instance, the positive energy district. When you want to look up for numbers in official databases, the boundaries are differently defined. So at the end, up to come up with a baseline of all these KPIs, you have to do simulations again to have at least numbers. But of course, you want to have real numbers from real devices, and that's exactly the problem with all KPIs at the moment.
Yeah, sure, and also the stakeholder needs are really changing, and the things that the people who use these neighborhoods vary really by from country to country. So it's a big challenge.
Okay.
Thank you. I just got a question from the audience that is, I think, a nice wrap-up question. And maybe it's, I'd like to propose that I ask each of the presenters to briefly respond to this question in 1 or 2 sentences. And the question is, what would, according to you, be the main drivers for a successful local energy community? What did you find? What is, in your view, an absolute necessity to make it successful? Is there anyone who would like to give a first answer?
Yeah, maybe I can start to break the ice. I think, in short, the secret, or one of the possibility is indeed to work with the multidisciplinary teams. So also the co-creation with the residents, and engaging from the bottom the solutions that are proposed. So definitely the 2 terms, one of the co-creation process and the multidisciplinarity of the teams engaged.
Thank you, Simona. Anyone else?
Yes, just,
yes.
Sorry, Anna.
Oh. Anna, please go ahead.
Okay, good. So I think the question, so driver for a successful energy community, it's a highly normative one. So successful is very subjective judgment. which depends on almost personal views of what's successful in that context. But I think that for me, in this context, I would say that this would be letting the communities decide what they want and let them participate and be part of the broader market, because right now this is not the case.
Thank you. That's very clear as well. Thank you, Anna. Rosa, would you like to add to that?
Yes, I would like to add to what already Simona and Anna said, that I think really the integration in the whole process, it's really important, linking to the multidisciplinary roles. But also what Anna mentioned, I think it is very true. Governance aspects and policy, like people need to feel the trust, that they can trust this new change that is coming. And most of the times our actions, we see in other projects that we are doing, actions are not be taken. There is an interest from the citizens, but at the end the action is not done because somehow they don't trust yet the system. And to do, we should really try to enable this much more.
Thank you. George, please. You're still muted. Or I can not hear you.
No, it's a small button. What I got from all the presentations today, but also from the other days, is that what we really need, in particularly for local communities, is to bridge the gap between the theory and the categorizations and all these theoretical stuff to best practices, and in particularly not only pilots but also viable business models, nice examples who could scale up by means of the platoon interoperability frameworks, that we make the onset to the transition really in practice. That's
Thank you.
A long-term aim, maybe.
Beril, sorry if I pronounced it wrong.
Yeah, Beril, it's okay. I just, of course, everybody said very right, accurate things, but I just would like to add that George is really right about the difference between the theory and the practice, because the socio-cultural behavior of the communities, it really changes from geography to geography, from country, and even in a country, all of the districts and regions of the country, it really changes. So it really depends on the collaborative governance attitude and the participatory design and the planning, and yes, these policies should be improved more in most of the countries.
Governance, participatory design, and the planning, you said.
Yeah.
I'm taking notes so that I can read this back to you afterwards. And there, sorry, just for my clarification, you think that these need to be considered better in order to enable communities to participate and have a say?
Yeah, policies should be improved on this issue.
On these issues,
yes. For every country, actually.
Thank you. Would anyone like to add to this?
Yeah, I just quickly say that everything, or not everything, but I think a lot has been said already. I personally think that to find the right mix of incentives for every stakeholder, let's say the government level, the EU level, the user level as well. So, for example, I find it interesting that in these energy marketplaces and peer-to-peer marketplaces, how or is it even possible to extend the existing environmental these cap and trade schemes to these neighborhood levels as well? So building these incentive levels not just from bottom up perspective, but also from a top-down perspective as well. It would be really interesting to see how that could play out.
Yeah. And that raises the question, if you want to have the right mix of incentives for all stakeholders and at all levels, what trade-offs will occur still?
Yeah, that's something I'm not sure.
No, of course I'm not asking for, but I can imagine that that's the next thing that needs to be a part of a dialogue or discussion among these stakeholders. Thank you. Iker, do you want to add something? I cannot hear you. I think you're not unmuted. While you try to unmute yourself, I just want to point out to the others that someone has posted a link from a nice examples on how to translate the highly sophisticated theoretical energy transitions to a wide audience. So please take a look at the chat box, everyone.
Iker, you're unmuted. Try to speak.
Can you hear me now?
Yes. There you are.
Yes. Okay. Sorry. I nearly forgot what I wanted to say. No, the thing is that of course it's difficult to just like Sylvia said, to find the right incentives for all the stakeholders. So I think that this should also be something educational. I think that the end users, especially, we should somehow educate on this. I don't know how to say it, like energy efficient lifestyle or whatever. It shouldn't be only the monetary incentive or all these kind of beneficial things. That's my
like
opinion.
a social norm change that starts with education, basically. Thank you. Philippe, you're not in the picture, but maybe you would like to have a final say if you're still around.
I'm still around. That's yeah, I think everything, not everything, but a lot of things was already said. So my point of view, I'm more on the technical side, but I think that you will never have two same energy community, so local energy community. So every energy community will be strongly influenced by the context. So the people who are building the community, the values they are sharing, the objective of the community, and of course the technical configuration, the infrastructure, the country, so it's become very relevant to look at this in this way, in the ways that you will design, build, and manage a local energy community, and to have, and now it's coming back again from my side, to have tools that are able to be so flexible and I don't like the term of agile, but are able to transform this view in something that is working in reality, because there is a big difference, like it was said, between concept theory and things. Yeah, we will do everything local energy community, but when you come in reality of physical system, electricity, and so on, that becomes a little bit more complicated. And that's the gap between what you try to do, which is wonderful and so on, and what you do at the end. And if you put on the top of this regulation and the strong difficulty of deploying new thing and so on, in some case, that, yeah, the thing is, yeah, is not easy to do. Yeah, perhaps that would be my 2 points, 2 cents.
Thank you for this, well, this systemic view as a final response to this question about the main drivers for energy communities. It is also 12:30, so time's up, basically. I would like to thank all the presenters very much for the interesting presentations. I would like to thank all participants for asking questions and making remarks. I will wrap up these final remarks by the presenters, and I'm not sure where I can share it. Zia, do you know? I can share it with the panelists, but I don't have the addresses of the audience. But I will share the final write-ups with Zia, and maybe it will find a way to you all at some point. Zia, thank you for the. Yes.
My pleasure. For anyone that wants to connect any dots or disseminate any information, please email sustainableplaces@r2msolution.com. And thanks very much, everyone.
Okay, thank you. Have a nice day, all of you.
Thanks,
you.
everyone. Thanks, Sylvia.
Bye-bye.
Thank you, Sylvia.